Deep in the vast expanse of the universe lies a galaxy that defies everything we thought we knew about space. NGC 1277, a cosmic enigma, is home to some of the most bizarre and mysterious objects ever discovered. From supermassive black holes that challenge our understanding of physics to ancient star clusters that whisper secrets of the early universe, this galaxy is a treasure trove of cosmic oddities. But what makes NGC 1277 truly extraordinary are the 50 strange objects hidden within its depths, each one more fascinating and perplexing than the last. In this video, we'll take you on an unforgettable journey through this galaxy, uncovering its secrets one object at a time. Are you ready to explore the unknown? Let's dive in. Now, let's turn our attention to the very heart of NGC 1277, where the first of our 50 strange objects resides, a supermassive black hole. This isn't just any black hole. It's a cosmic giant that challenges everything we thought we knew about these mysterious entities. At its core, this black hole is so massive that it dwarfs even the most colossal black holes we've discovered in other galaxies. Scientists estimate its mass to be billions of times greater than that of our Sun, making it one of the most massive black holes ever observed. But here's where things get truly mind-bending. According to our current understanding of black hole formation, a black hole of this size shouldn't exist in a galaxy as small as NGC 1277. Typically, supermassive black holes are found in much larger galaxies where they grow over billions of years by consuming stars, gas, and even other black holes. Yet, this one defies the rules, raising questions about how it could have formed so quickly, or if there's something entirely different at play. Its gravitational pull is so intense that it warps the very fabric of space and time around it, creating a region where the laws of physics as we know them begin to break down. This supermassive black hole isn't just a cosmic oddity, it's a puzzle that could rewrite our understanding of how galaxies and black holes evolve. And as we continue our journey through NGC 1277, this is just the first of many mysteries waiting to be unraveled. Now, shifting our gaze outward from the supermassive black hole, we encounter another cosmic enigma cloaking NGC 1277, the dark matter halo. Unlike the black hole, which we can observe indirectly through its gravitational effects, dark matter is entirely invisible. It doesn't emit, absorb, or reflect light, making it one of the most elusive substances in the universe. Yet, its presence is undeniable. This massive halo of dark matter envelops NGC 1277, acting as an invisible scaffold that holds the galaxy together. Without it, the galaxy's stars and gas would simply fly apart, unable to maintain their structure against the forces of gravity and motion. But what exactly is dark matter? Scientists believe it's a type of matter that doesn't interact with electromagnetic forces, meaning it doesn't produce light or energy we can detect. Instead, its existence is inferred through its gravitational influence on visible matter, like stars and gas clouds. In the case of NGC 1277, the dark matter halo is thought to be incredibly dense, far more so than in most other galaxies. This density raises intriguing questions. Why is there so much dark matter here? How did it accumulate in such vast quantities? And what role did it play in the formation of the galaxy itself? One theory suggests that dark matter acted as a cosmic seed, drawing in gas and dust to form the first stars and eventually the galaxy we see today. Another possibility is that the dark matter halo has grown over time, merging with smaller halos from neighboring galaxies. Yet, despite decades of research, dark matter remains one of the greatest mysteries in modern astrophysics. It's a reminder that even in a galaxy as strange as NGC 1277, some of the most profound questions are still waiting for answers. As we move forward, this invisible halo serves as a silent guardian, shaping the galaxy's destiny while keeping its secrets hidden. And as we'll soon discover, NGC 1277 has even more surprises in store. Now, as we venture deeper into the mysteries of NGC 1277, we come across a celestial treasure that has stood the test of time, an ancient star cluster. This cluster is not just a collection of stars, it's a window into the early universe, offering us a glimpse of what the cosmos looked like billions of years ago. This star cluster is one of the oldest known structures in the galaxy, with an estimated age of over 10 billion years. To put that into perspective, it formed when the universe itself was still in its infancy, just a fraction of its current age. The stars within this cluster are ancient relics composed primarily of hydrogen and helium, the simplest and most abundant elements in the early universe. Unlike younger stars, which contain heavier elements forged in the hearts of earlier generations of stars, these ancient stars are almost pure, untouched by the chemical evolution that came later. What makes this cluster so fascinating is what it tells us about the conditions of the early universe. The stars here are like cosmic time capsules, preserving the chemical makeup of the universe as it was shortly after the Big Bang. By studying their composition, astronomers can piece together how the first stars and galaxies formed. For instance, the lack of heavier elements in these stars suggests that they were born in an era before supernova had spread metals across the cosmos. This gives us critical insights into the processes that shaped the universe in its formative years. But the story doesn't end there. The cluster's location within NGC 1277 adds another layer of intrigue. How did such an ancient structure survive the tumultuous history of galaxy formation and evolution? One theory is that it formed in a relatively quiet corner of the early universe, shielded from the violent collisions and mergers that reshaped other regions. Another possibility is that it was once part of a smaller galaxy that was absorbed by NGC 1277, preserving the cluster as a fossil of that earlier cosmic era. As we study this ancient star cluster, we're not just looking at stars, we're unraveling the history of the universe itself. It's a reminder that even in a galaxy as strange and dynamic as NGC 1277, some of the most profound discoveries come from the oldest and quietest corners of space. And as we continue our journey, we'll uncover even more secrets hidden within this extraordinary galaxy. Moving forward in our exploration of NGC 1277, we now encounter a phenomenon that seems almost otherworldly, a ghostly gas cloud drifting silently through the galaxy. This isn't your typical interstellar cloud. It's a peculiar structure that emits faint, almost imperceptible radiation, making it a fascinating yet elusive subject for astronomers. This ghostly gas cloud is unlike anything we've seen before. While most gas clouds in space are known for their vibrant emissions, often glowing brightly due to the energy from nearby stars, this one is eerily dim. Its faint radiation is so subtle that it was only detected using highly sensitive instruments designed to pick up the faintest signals in the cosmos. What makes this cloud so unusual is its composition. Unlike typical interstellar clouds, which are rich in hydrogen and helium, this one contains traces of rare elements and molecules that are rarely found in such concentrations. The presence of these rare elements raises intriguing questions. How did this cloud form, and why does it emit such faint radiation? One theory suggests that it could be the remnant of a long-dead star, a cosmic ghost lingering in the void. When massive stars die, they often expel their outer layers into space, creating clouds of gas and dust. Over time, these clouds can cool and fade, becoming faint shadows of their former selves. This ghostly cloud might be the final whisper of a star that burned out billions of years ago. Another possibility is that this cloud is a relic from an ancient galactic collision. When galaxies collide, the immense forces involved can strip gas and dust from their structures, scattering them across vast distances. This cloud could be a fragment of such an event, drifting through NGC 1277 as a silent witness to the galaxy's turbulent past. What truly challenges our understanding, however, is the cloud's faint radiation. Normally, gas clouds emit light when they are energized by nearby stars or other sources of heat. But this cloud seems to glow on its own, albeit faintly, without any obvious external energy source. This has led scientists to speculate that it might contain exotic particles or processes that we have yet to discover. Could it be interacting with dark matter or perhaps harboring some unknown form of energy? The answers remain elusive, but the questions it raises are reshaping how we think about interstellar matter. As we study this ghostly gas cloud, we're reminded that even the faintest objects in the cosmos can hold profound secrets. It challenges our assumptions and pushes the boundaries of what we know about the universe. And as we continue our journey through NGC 1277, we'll uncover even more mysteries that defy explanation, each one adding a new piece to the puzzle of this extraordinary galaxy. Now, let's turn our attention to another fascinating object in NGC 1277, a rogue planet drifting aimlessly through the vast expanse of the galaxy. Unlike the planets in our solar system, which orbit a star, this rogue planet is a cosmic wanderer untethered from any stellar parent. It's a world without a sun, moving through the darkness of space, and its existence challenges our understanding of how planets form and survive. So, how did this rogue planet end up in NGC 1277? One possibility is that it was once part of a planetary system, orbiting a star just like Earth orbits the Sun. But something catastrophic happened, perhaps a close encounter with another massive object or the gravitational pull of a passing star, that flung it out of its orbit, sending it hurtling into the void. Another theory suggests that it might have formed on its own, emerging from a collapsing cloud of gas and dust without ever being bound to a star. These rogue planets, sometimes called free-floating planets, are thought to be surprisingly common in the universe, though they're incredibly difficult to detect due to their lack of light. What makes this rogue planet in NGC 1277 so unique is its sheer isolation. In our solar system, planets are shaped by the heat and light of the Sun, which influences their atmospheres, climates, and even the potential for life. But this rogue planet exists in perpetual darkness with no star to warm its surface. Despite this, it might not be entirely lifeless. Some scientists speculate that rogue planets could harbor subsurface oceans, kept liquid by internal heat from radioactive decay or tidal forces. If that's the case, this lonely world could be a hidden oasis in the cold depths of space. Another intriguing aspect of this rogue planet is its size. Observations suggest it's significantly larger than Earth, possibly even rivaling the gas giants like Jupiter. Yet without a star to illuminate it, it remains shrouded in mystery. Its atmosphere, if it has one, could be unlike anything we've seen before, composed of exotic gases or even frozen into solid layers due to the extreme cold. Studying this planet could provide clues about the diversity of planetary systems and the conditions under which they form. As we ponder the existence of this rogue planet, we're reminded of the vastness and unpredictability of the cosmos. It's a world that defies our expectations, challenging us to rethink what we know about planets and their place in the universe. And as we continue our journey through NGC 1277, we'll encounter even more objects that push the boundaries of our imagination, each one revealing a new layer of the galaxy's incredible story. Now, let's shift our gaze to one of the most spectacular events in the cosmos, a pair of galaxies within NGC 1277 that are locked in a cosmic dance, slowly merging into one. This collision is not just a fleeting moment in the life of the universe. It's a transformative event that reshapes everything in its path, creating some of the strangest and most fascinating objects we've ever observed. When two galaxies collide, it's not like two cars crashing into each other. Instead, it's a slow, intricate process that can take hundreds of millions of years. The galaxies are mostly empty space, so their stars rarely collide. Instead, their immense gravitational forces pull and twist each other, creating stunning tidal tails, bridges of gas, and swirling patterns of light. These gravitational interactions can trigger bursts of star formation, lighting up the galaxies with newborn stars and supernovas. It's like a cosmic fireworks display, but on a scale that's almost impossible to comprehend. One of the most dramatic effects of this collision is the creation of new, massive star clusters. As the gas and dust from the two galaxies compress and collide, they form dense regions where stars are born at an incredible rate. These clusters can contain thousands or even millions of stars, packed tightly together in a dazzling display of cosmic energy. Some of these clusters are so bright and massive that they outshine entire galaxies, becoming beacons of light in the chaos of the merger. But the collision doesn't just create stars, it also gives birth to some truly bizarre objects. For example, the intense gravitational forces can fling stars and even entire star systems out of the galaxies, sending them hurtling into intergalactic space as hypervelocity stars. These rogue stars, much like the rogue planet we discussed earlier, become cosmic wanderers untethered from their galactic homes. Additionally, the collision can trigger the formation of supermassive black holes at the center of the new, merged galaxy. These black holes can grow to incredible sizes, devouring gas, dust, and even stars as they spiral closer together, eventually merging into a single, even more massive black hole. The collision also distorts the shapes of the galaxies, creating strange and beautiful structures. One galaxy might stretch out into a long, thin filament, while the other becomes a swirling vortex of gas and stars. Over time, these distortions settle, and the two galaxies merge into a single, larger galaxy. This new galaxy will have a completely different structure and composition than either of its predecessors, a testament to the transformative power of cosmic collisions. As we observe this incredible event, we're reminded of the dynamic and ever-changing nature of the universe. Galaxies, like all things in the cosmos, are not static. They grow, evolve, and interact in ways that shape the fabric of space itself. And as we continue our journey through NGC 1277, we'll encounter even more wonders, each one revealing a new chapter in the galaxy's extraordinary story. Now, let's turn our attention to one of the most enigmatic remnants in the cosmos, a quasar remnant nestled within the depths of NGC 1277. Quasars, often referred to as the brightest objects in the universe, are powered by supermassive black holes at the centers of galaxies. These black holes devour enormous amounts of gas and dust, releasing staggering amounts of energy in the process. This energy is so intense that it can outshine entire galaxies, making quasars visible across vast cosmic distances. But what happens when a quasar fades? That's where this remnant comes into play. The quasar remnant in NGC 1277 is a rare and fascinating relic of a once active quasar. It's like finding the ashes of a long-extinguished fire, still glowing faintly with the memory of its former brilliance. This remnant offers us a unique glimpse into the life cycle of quasars and the supermassive black holes that power them. Unlike active quasars, which are still consuming matter and shining brightly, this remnant has entered a quieter phase. The black hole at its center has either exhausted its fuel or is no longer feeding at the same voracious rate, leaving behind a ghostly echo of its past activity. What makes this remnant particularly intriguing is its structure. Surrounding the dormant black hole is a vast cloud of ionized gas, glowing faintly as it continues to interact with the black hole's gravitational pull. This gas is a remnant of the material that once fueled the quasar's intense radiation. Over time, this cloud will dissipate, but for now, it serves as a cosmic time capsule, preserving the conditions of the quasar's active phase. By studying this remnant, astronomers can piece together the history of the quasar and gain insights into how these powerful objects evolve over billions of years. Another fascinating aspect of this quasar remnant is its rarity. While active quasars are relatively common in the early universe, remnants like this one are much harder to find. This is because the transition from an active quasar to a remnant is a slow and subtle process, often leaving behind few observable traces. The fact that we've discovered such a remnant in NGC 1277 is a testament to the galaxy's rich and complex history, offering us a rare opportunity to study the aftermath of one of the universe's most energetic events. As we explore this quasar remnant, we're reminded of the dynamic and ever-changing nature of the cosmos. Even the brightest and most powerful objects eventually fade, leaving behind clues that help us unravel the mysteries of the universe. And as we continue our journey through NGC 1277, we'll encounter even more wonders, each one adding another piece to the puzzle of this extraordinary galaxy. Now, shifting our gaze to another cosmic marvel, let's explore the neutron star within NGC 1277. Neutron stars are the remnants of massive stars that have exhausted their nuclear fuel and collapsed under their own gravity. What remains is an incredibly dense object, packing the mass of about 1.4 times that of our Sun into a sphere no larger than a city. To put that into perspective, a single teaspoon of neutron star material would weigh as much as a mountain. This mind-boggling density is just one of the many features that make neutron stars so extraordinary. But density isn't the only thing that sets neutron stars apart. These objects are also home to some of the most intense magnetic fields in the universe. Known as magnetars, some neutron stars have magnetic fields trillions of times stronger than Earth. These fields are so powerful that they can distort the structure of atoms and even affect space-time itself. The neutron star in NGC 1277, while not classified as a magnetar, still boasts a magnetic field strong enough to influence its surroundings in dramatic ways. This magnetic power can accelerate particles to near light speeds, creating bursts of radiation that can be detected across vast distances. The extreme conditions on and around a neutron star are unlike anything we experience on Earth. The surface gravity is so intense that it would crush any known material, and the temperatures can reach millions of degrees. Yet, despite these harsh conditions, neutron stars are also incredibly precise cosmic clocks. Many of them rotate at astonishing speeds, some completing hundreds of rotations per second. This rapid spin, combined with their strong magnetic fields, makes them emit beams of radiation that sweep across space like a lighthouse. When these beams point toward Earth, we detect them as pulsars, providing astronomers with a wealth of information about these enigmatic objects. What makes the neutron star in NGC 1277 particularly fascinating is its role in the galaxy's history. As a remnant of a once massive star, it serves as a reminder of the violent processes that shape galaxies over time. The supernova explosion that created this neutron star would have released an enormous amount of energy, influencing the surrounding gas and dust and potentially triggering the formation of new stars. By studying this neutron star, scientists can gain insights into the life cycles of stars and the dynamic processes that drive galactic evolution. As we continue our journey through NGC 1277, the neutron star stands as a testament to the extremes of the universe. It challenges our understanding of matter, gravity, and magnetism, offering a glimpse into the incredible forces at work in the cosmos. And as we move forward, we'll uncover even more strange and wondrous objects, each one adding to the rich tapestry of this mysterious galaxy. Now, let's turn our attention to something truly mind-bending: the cosmic string detected in NGC 1277. Cosmic strings are theoretical, one-dimensional objects, often described as cracks or wrinkles in the fabric of spacetime itself. Imagine the universe as a vast, smooth sheet. A cosmic string would be like a tiny, incredibly thin thread running through that sheet, but with a twist. This thread has immense gravitational effects that can warp space and time around it. While cosmic strings have yet to be definitively proven, their potential discovery in NGC 1277 opens up a world of possibilities for understanding the universe on a deeper level. What makes cosmic strings so fascinating is their connection to the early universe. Scientists believe these strings could have formed just moments after the Big Bang, during a phase when the universe was cooling and undergoing rapid changes. Think of it like water freezing into ice. Sometimes cracks form as the material transitions. In the case of the universe, these cracks could have become cosmic strings, remnants of a time when the cosmos was still taking shape. If the cosmic string in NGC 1277 is confirmed, it would provide a rare glimpse into the universe's infancy, offering clues about how everything we see today came to be. But the implications of cosmic strings go far beyond just understanding the early universe. These objects are thought to have such intense gravitational fields that they could bend light, create distortions in spacetime, and even produce ripples known as gravitational waves. In fact, some theories suggest that cosmic strings might be responsible for certain patterns in the cosmic microwave background radiation, the faint afterglow of the Big Bang. By studying the cosmic string in NGC 1277, scientists could test these theories and refine our understanding of how gravity and spacetime interact on the largest scales. One of the most intriguing aspects of cosmic strings is their potential to challenge our current understanding of physics. For instance, they could provide evidence for theories that go beyond Einstein's general relativity, such as string theory or quantum gravity. These theories attempt to unify the forces of nature and explain phenomena that classical physics cannot. If the cosmic string in NGC 1277 behaves in ways that current models can't fully explain, it could open the door to entirely new ways of thinking about the universe. As we continue to explore NGC 1277, the cosmic string stands out as a tantalizing mystery. It's a reminder that the universe is full of surprises and that even the most theoretical ideas can have real-world implications. Whether it's bending light, creating gravitational waves, or offering a window into the early cosmos, this cosmic string challenges us to rethink what we know about space, time, and the very fabric of reality. And as we move forward, we'll uncover even more strange and wondrous objects, each one adding to the rich tapestry of this mysterious galaxy. Now, let's shift our gaze to a celestial speedster tearing through the vast expanse of NGC 1277, the hypervelocity star. This star isn't just fast, it's racing through space at speeds that defy imagination, moving so quickly that it could one day escape the galaxy entirely. But how does a star reach such incredible velocities? The answer lies in one of the most dramatic events in the universe, a close encounter with a supermassive black hole. Picture this: a star wanders too close to the gravitational pull of a black hole. Instead of being swallowed whole, it gets slingshotted away at an astonishing speed, like a cosmic pinball launched by the black hole's immense gravity. This process, known as the gravitational slingshot effect, is what likely propelled this hypervelocity star on its high-speed journey. In the case of NGC 1277, the supermassive black hole at its center is the prime suspect behind this star's incredible acceleration. But the story doesn't end there. Once set in motion, this star becomes a cosmic traveler, hurtling through the galaxy at speeds that can reach millions of miles per hour. Its trajectory is so extreme that it could eventually break free from the gravitational grip of NGC 1277, venturing into intergalactic space. Imagine a lone star, untethered from its home galaxy, drifting through the vast emptiness between galaxies, a true cosmic nomad. What makes hypervelocity stars so fascinating is not just their speed, but what they reveal about the forces at play in the universe. By studying their paths, astronomers can learn more about the gravitational dynamics of black holes and the environments around them. These stars act like cosmic probes, carrying information about the extreme conditions that launched them on their journey. In the case of the hypervelocity star in NGC 1277, its trajectory could even provide clues about the galaxy's history and the behavior of its central black hole. As we watch this star race across the galaxy, it's a reminder of the incredible forces that shape our universe. From the immense gravity of black holes to the sheer speed of stars flung into the void, NGC 1277 continues to surprise us with its strange and wondrous objects. And as we follow the path of this hypervelocity star, we're left to wonder, where will it go next and what secrets will it carry with it into the unknown? Now, let's turn our attention to one of the most enigmatic and elusive objects in NGC 1277, the dark star. Unlike the blazing stars we're familiar with, a dark star is a hypothetical object that doesn't shine in the way we'd expect. Instead, it's thought to be composed of exotic matter, possibly even dark matter, which makes it invisible to traditional telescopes. But what exactly is a dark star, and why does it remain hidden from our view? Imagine a star that doesn't emit light or heat in the way ordinary stars do. A dark star is theorized to form in the early universe, where vast clouds of dark matter could have collapsed under their own gravity, creating a dense, invisible core. Unlike regular stars, which generate energy through nuclear fusion, a dark star might rely on the annihilation of dark matter particles to produce energy. This process would release very little visible light, making it nearly impossible to detect using conventional methods. So, why is this object so hard to find? The answer lies in its very nature. Dark stars, if they exist, would emit almost no electromagnetic radiation, meaning they wouldn't glow in the visible ultraviolet or infrared spectrums. Instead, their presence might only be inferred through their gravitational effects on surrounding objects. For example, if a dark star were orbiting another star, its gravitational pull could cause subtle wobbles in the visible star's motion, a clue that something unseen is lurking nearby. The idea of dark stars challenges our understanding of stellar formation and the role of dark matter in the universe. If confirmed, they could provide crucial insights into the nature of dark matter itself, a substance that makes up a significant portion of the universe's mass but remains one of its greatest mysteries. In NGC 1277, the search for dark stars adds another layer of intrigue to this already fascinating galaxy, as astronomers continue to explore the possibility of these invisible giants hiding in plain sight. As we ponder the existence of dark stars, we're reminded of how much of the universe remains unseen and unexplained. These hypothetical objects push the boundaries of our knowledge, inviting us to rethink what we know about stars, matter, and the cosmos itself. Could NGC 1277 be home to one of these elusive dark stars? Only time and further exploration will tell. Now, shifting our gaze to another cosmic spectacle within NGC 1277, we encounter a phenomenon that's as fascinating as it is destructive: the galactic cannibal. This isn't a creature from science fiction, but rather a galaxy that's actively devouring its smaller neighbors. Yes, galaxies can be cannibals too, and the process is as dramatic as it sounds. Picture this: a massive galaxy with its immense gravitational pull, slowly drawing in smaller galaxies that venture too close. Over millions of years, these smaller galaxies are torn apart, their stars, gas, and dust absorbed into the larger galaxy. This process, known as galactic cannibalism, is a violent yet mesmerizing dance of cosmic forces. The remnants of these consumed galaxies often form strange structures like streams of stars or glowing clouds of gas scattered across the cannibal galaxy's outskirts. But what makes this process so intriguing is what it leaves behind. As the smaller galaxies are ripped apart, their stars are redistributed, creating intricate patterns and trails that tell the story of their demise. These stellar streams can stretch for thousands of light years, weaving through the cannibal galaxy like cosmic graffiti. Additionally, the influx of new material can trigger bursts of star formation, lighting up the cannibal galaxy with newborn stars and glowing nebulae. In NGC 1277, this galactic cannibal offers a unique opportunity to study the aftermath of such cosmic collisions. By observing the remnants of these consumed galaxies, astronomers can piece together the history of these interactions and better understand how galaxies grow and evolve over time. It's a reminder that even in the vastness of space, nothing is truly isolated. Galaxies, like stars, are constantly interacting, merging, and reshaping one another. As we marvel at the galactic cannibal, we're reminded of the dynamic and ever-changing nature of the universe. These cosmic feasts not only shape the galaxies involved, but also leave behind a trail of clues that help us unravel the mysteries of galactic evolution. NGC 1277, with its cannibalistic tendencies, continues to challenge our understanding of the cosmos, offering a glimpse into the violent yet beautiful processes that drive the universe forward. Now, let's turn our attention to something that sounds like it belongs in the realm of science fiction, but might just be one of the most groundbreaking discoveries in physics: the magnetic monopole. Unlike the magnets we're familiar with, which always have a north and a south pole, a magnetic monopole is a hypothetical particle that possesses only one magnetic pole. Imagine a magnet with just a north pole and no south pole, or vice versa. It's a concept that has puzzled scientists for decades, and NGC 1277 might hold the key to unraveling this mystery. The idea of a magnetic monopole isn't new. In fact, it was first proposed by physicist Paul Dirac in the 1930s as a way to explain why electric charge comes in discrete units. According to Dirac's theory, the existence of even a single magnetic monopole would explain why electric charge is quantized, meaning it comes in specific, indivisible amounts. This would be a monumental discovery, as it would bridge a gap in our understanding of electromagnetism, one of the fundamental forces of nature. So, why are magnetic monopoles so rare, and why is their detection in NGC 1277 such a big deal? For starters, magnetic monopoles are thought to have formed in the early universe, during a phase transition when the universe was cooling down after the Big Bang. These particles would have been incredibly massive and unstable, making them difficult to detect. Over time, as the universe expanded, they became even rarer, scattered across vast cosmic distances. Finding one today would be like finding a needle in a galaxy-sized haystack. In NGC 1277, astronomers have detected unusual magnetic fields that could hint at the presence of a magnetic monopole. These fields don't behave like those produced by ordinary magnets, which always have two poles. Instead, they exhibit patterns that align with what scientists would expect from a monopole. While this discovery is still theoretical and requires further verification, it's an exciting step toward confirming the existence of these elusive particles. The significance of finding a magnetic monopole goes beyond just physics. It would revolutionize our understanding of the universe, providing insights into the fundamental laws that govern everything from subatomic particles to the largest structures in the cosmos. It could also open the door to new technologies, such as advanced magnetic storage systems or even entirely new forms of energy. As we ponder the implications of this discovery, we're reminded of how much we still have to learn about the universe. NGC 1277, with its potential magnetic monopole, continues to challenge our understanding of physics, offering a tantalizing glimpse into the mysteries that lie at the heart of reality. And who knows, this strange object might just be the key to unlocking one of the greatest secrets of the cosmos. Now, let's shift our gaze to another marvel hidden within the depths of NGC 1277, a truly extraordinary exoplanet adorned with a ring system so vast it makes Saturn's iconic rings look modest by comparison. This distant world, orbiting a star far beyond our solar system, is a spectacle that challenges our understanding of planetary formation and the diversity of celestial objects in the universe. Unlike Saturn, which boasts rings made primarily of ice and rock, this exoplanet's ring system is believed to be composed of a mix of dust, gas, and possibly even larger fragments of material. The sheer scale of these rings is staggering, stretching out to distances that dwarf anything we've observed in our own cosmic neighborhood. To put it into perspective, if Saturn's rings were the size of a basketball hoop, this exoplanet's rings would span the length of an entire football field. It's a breathtaking sight, even if only imagined through the lens of scientific data. But how did such a massive ring system form? One theory suggests that the exoplanet may have once had a moon or moons that were torn apart by the planet's intense gravitational forces. Over time, the debris from these shattered moons could have coalesced into the expansive rings we see today. Another possibility is that the rings are the remnants of a protoplanetary disk, the swirling cloud of gas and dust from which planets form. In this scenario, the exoplanet's gravity could have captured and held onto a significant portion of this material, creating its stunning ring system. What makes this discovery even more fascinating is the potential for these rings to act as a cosmic laboratory. By studying their composition and structure, scientists can gain insights into the processes that shape planetary systems, not just in NGC 1277 but across the universe. For instance, the presence of certain materials in the rings could reveal clues about the exoplanet's atmosphere, its history of collisions, or even the conditions of its parent star. As we marvel at this exoplanet and its colossal rings, we're reminded of the incredible diversity of worlds that exist beyond our solar system. NGC 1277 continues to surprise us, offering a glimpse into the many ways planets can form and evolve. And while we may never see this distant world up close, its existence challenges us to rethink what we know about the cosmos and the endless possibilities it holds. Next, we'll explore another strange object in NGC 1277, a nebula unlike any other, floating between galaxies and defying our expectations of what these cosmic clouds can be. Stay tuned as we uncover more of the galaxy's secrets. Now, let's venture into the vast emptiness between galaxies where a truly peculiar object awaits our attention, an intergalactic nebula. Unlike the nebulae we're familiar with, which are often found within galaxies, this one floats freely in the void, a ghostly cloud of gas and dust suspended between the stars of NGC 1277 and its neighboring galaxies. It's a cosmic oddity that challenges our understanding of where and how these structures can exist. What makes this nebula so unique? For starters, its location is unlike anything we've seen before. Most nebulae are born within galaxies, formed from the remnants of dying stars or the raw materials of star formation. But this intergalactic nebula exists in a space so empty, so devoid of stars, that its very presence is a mystery. How did it form? What keeps it intact in such a sparse environment? These are questions that have astronomers scratching their heads. One possibility is that this nebula is a relic of a galactic collision. When two galaxies pass close to one another, their gravitational forces can pull gas and dust out into the space between them, creating a bridge of material. Over time, this bridge might collapse into a nebula, drifting alone in the void. Another theory suggests that the nebula could be the remnants of a galaxy that was torn apart by the immense gravitational forces of NGC 1277, leaving behind only this wispy cloud as evidence of its former existence. The composition of this nebula is also intriguing. Unlike typical nebulae, which are often rich in hydrogen and helium, this intergalactic cloud contains traces of heavier elements like carbon, oxygen, and even iron. These elements are usually forged in the hearts of stars, suggesting that this nebula might have once been part of a star-forming region before being ejected into the void. Its unique chemistry could provide clues about the history of NGC 1277 and the violent events that shaped its surroundings. But perhaps the most fascinating aspect of this nebula is its sheer isolation. Floating in the darkness between galaxies, it's a lonely sentinel, untouched by the gravitational pull of any single galaxy. This makes it a rare opportunity for scientists to study a nebula in its purest form, free from the influence of nearby stars or galactic structures. By analyzing its light and composition, astronomers can learn more about the processes that govern the life and death of these cosmic clouds. As we ponder this intergalactic nebula, we're reminded of the vastness of space and the countless mysteries it holds. NGC 1277 continues to surprise us, offering glimpses of phenomena that defy our expectations and expand our understanding of the universe. And as we move forward, we'll uncover even more of its secrets, each one a piece of the cosmic puzzle waiting to be solved. Next, we'll turn our attention to a region in NGC 1277 where time itself seems to bend and slow, a place where the laws of physics take on a whole new meaning. Stay with us as we explore this mind-bending phenomenon. Now, let's step into one of the most mind-bending regions of NGC 1277, a place where time itself seems to warp and stretch. This area, known as the time dilation zone, is a cosmic anomaly where the flow of time slows down relative to the rest of the galaxy. It's a phenomenon that sounds like something straight out of science fiction, but it's rooted in the very real principles of Einstein's theory of relativity. So, how does time dilation work? At its core, it's all about gravity. According to Einstein, massive objects like black holes or dense clusters of stars can warp the fabric of spacetime. The stronger the gravitational pull, the more spacetime bends and the slower time moves. In this region of NGC 1277, the gravitational forces are so intense that they create a noticeable slowdown in time. If you were to observe a clock in this zone from a distance, it would tick more slowly compared to one outside the zone. It's a strange and fascinating effect that challenges our everyday experience of time as a constant, unchanging force. But what causes such extreme gravity in this part of the galaxy? One possibility is the presence of a supermassive black hole or a dense cluster of stars nearby. These objects exert an immense gravitational pull, bending spacetime to the point where time dilation becomes observable. Another theory suggests that this region might be influenced by dark matter, the mysterious substance that makes up a significant portion of the universe's mass. If dark matter is concentrated here, it could amplify the gravitational effects, creating this time-slowing zone. The implications of time dilation are profound, not just for our understanding of NGC 1277, but for the universe as a whole. For one, it provides a real-world example of Einstein's predictions in action, offering scientists a unique opportunity to test and refine our theories of gravity and spacetime. It also raises intriguing questions about how time operates in extreme environments. Could there be regions in the universe where time moves even slower or faster? And what would that mean for the way we perceive reality? This time dilation zone also has practical implications for space exploration. If humans were ever to travel near such a region, they would experience time differently compared to those on Earth. A journey that feels like a few years to the travelers might span decades or even centuries for those left behind. It's a concept that highlights the strange and wondrous nature of the cosmos, reminding us that the universe is far more complex and mysterious than we often realize. As we explore this time dilation zone, we're reminded of the incredible power of gravity and the ways it shapes the fabric of reality. NGC 1277 continues to challenge our understanding of the universe, offering glimpses of phenomena that push the boundaries of science and imagination. And as we move forward, we'll uncover even more of its secrets, each one a step closer to unraveling the mysteries of time and space. Next, we'll turn our attention to another cosmic marvel, a filament of the cosmic web that threads its way through NGC 1277, connecting galaxies across the vast expanse of the universe. Stay with us as we explore this intricate network of matter and energy. Now, let's shift our gaze to another extraordinary feature of NGC 1277, a filament of the cosmic web. This vast thread-like structure is part of the intricate network that connects galaxies across the universe, forming the backbone of the cosmos itself. Imagine the universe as a sprawling spiderweb with galaxies strung along its delicate strands. This filament in NGC 1277 is one such strand, a highway of matter and energy that stretches across unimaginable distances. The cosmic web is the large-scale structure of the universe, a framework built from dark matter and gas that shapes the distribution of galaxies. These filaments act like cosmic bridges, linking clusters of galaxies and guiding the flow of matter. In NGC 1277, this filament serves as a vital connection, channeling gas and other materials that fuel star formation and galaxy growth. Without these filaments, the universe would be a far more chaotic and disconnected place. But what exactly makes up these filaments? They're primarily composed of dark matter, the invisible substance that makes up about 85% of the universe's mass. Dark matter's gravitational pull draws ordinary matter like gas and dust into these long, thin strands. Along these filaments, galaxies form and evolve, clustering together like beads on a string. The filament in NGC 1277 is no exception, playing a crucial role in the galaxy's development and its interactions with neighboring galaxies. One of the most fascinating aspects of the cosmic web is how it reveals the universe's history. These filaments are remnants of the early universe, formed in the aftermath of the Big Bang. As the universe expanded, tiny fluctuations in density grew into the vast network we see today. By studying filaments like the one in NGC 1277, scientists can trace the evolution of the cosmos, uncovering clues about how galaxies, stars, and even planets came to be. The filament in NGC 1277 also highlights the interconnectedness of the universe. It's a reminder that no galaxy exists in isolation. Each one is part of a larger tapestry, shaped by the forces of gravity and the flow of matter along these cosmic highways. This filament not only connects NGC 1277 to other galaxies, but also influences its growth, feeding it with the raw materials needed to form new stars and sustain its structure. As we explore this filament, we gain a deeper appreciation for the universe's complexity and beauty. It's a testament to the power of gravity and the delicate balance that governs the cosmos. NGC 1277 filament is more than just a thread in the cosmic web. It's a lifeline, a bridge, and a window into the universe's past and future. Next, we'll delve into an even more mysterious feature of NGC 1277, a structure so unusual that some have speculated it could be an alien megastructure. Stay with us as we uncover the secrets of this enigmatic object. Now, let's turn our attention to one of the most intriguing mysteries in NGC 1277, a structure so unusual that it has sparked wild speculation and debate among scientists and enthusiasts alike. Could this be evidence of an alien megastructure? The idea might sound like science fiction, but the peculiar features of this object have led some to consider the possibility. This mysterious structure, located within NGC 1277, stands out due to its irregular shape and unusual energy emissions. Unlike typical celestial objects, it doesn't fit neatly into any known category. Its light patterns are inconsistent, and its energy output fluctuates in ways that defy conventional explanations. These anomalies have fueled theories that it might be an artificial construct, a megastructure built by an advanced extraterrestrial civilization. One of the leading theories suggests that this structure could be a Dyson sphere, a hypothetical megastructure designed to harness the energy of a star. While Dyson spheres are often imagined as solid shells, they could also take the form of a swarm of orbiting satellites or panels. If this structure in NGC 1277 is indeed a Dyson sphere, it would represent an engineering feat far beyond anything humanity has achieved. The sheer scale of such a project would require technology and resources that are almost unimaginable. However, not everyone is convinced. Skeptics argue that there are natural explanations for the structure's peculiarities. For instance, it could be a rare cosmic phenomenon, such as a dense cluster of stars obscured by dust or a massive black hole surrounded by an unusually active accretion disk. These natural explanations, while less sensational, are still fascinating in their own right and highlight the complexity of the universe. The debate over this structure's true nature underscores the challenges of studying distant galaxies. With current technology, it's difficult to gather definitive evidence. Observations are limited by the vast distances involved, and even the most advanced telescopes can only provide glimpses of what's happening in NGC 1277. This uncertainty leaves room for speculation and imagination, making the alien megastructure theory both compelling and controversial. What makes this object particularly captivating is its potential to challenge our understanding of the universe. If it were proven to be artificial, it would revolutionize our perspective on life beyond Earth. It would suggest that advanced civilizations exist, or once existed, in the cosmos, capable of constructing megastructures on an unimaginable scale. Even if it turns out to be a natural phenomenon, studying it could reveal new insights into the processes that shape galaxies and the universe itself. As we continue to explore NGC 1277, this mysterious structure remains a tantalizing enigma. Whether it's a product of alien engineering or a rare cosmic event, it serves as a reminder of how much we still have to learn about the universe. The search for answers continues, and with each new discovery, we come closer to unraveling the secrets of this extraordinary galaxy. Next, we'll examine another fascinating feature of NGC 1277, the remnants of a gamma-ray burst, one of the most powerful explosions in the universe. Stay tuned as we uncover the story behind this cosmic cataclysm. Now, let's shift our focus to one of the most dramatic events in the cosmos, a gamma-ray burst remnant within NGC 1277. These bursts are among the most powerful explosions in the universe, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. The remnants of such an event in NGC 1277 offer a glimpse into the violent and chaotic processes that shape galaxies. Gamma-ray bursts are typically caused by the collapse of massive stars or the collision of neutron stars. In the case of NGC 1277, scientists believe this particular burst originated from the death of a colossal star, one many times more massive than our Sun. As the star exhausted its nuclear fuel, its core collapsed, triggering a cataclysmic explosion that sent shockwaves rippling through space. the burst itself would have been blindingly bright, visible across vast cosmic distances, even if only for a fleeting moment. The aftermath of such an explosion is equally fascinating. The gamma-ray burst remnant in NGC 1277 is a swirling cloud of superheated gas and debris, enriched with heavy elements forged in the heart of the dying star. These elements, including gold, platinum, and uranium, are scattered across the galaxy, seeding future generations of stars and planets. In a way, this remnant is a cosmic recycler, transforming the remnants of a dead star into the building blocks of new worlds. But the impact of a gamma-ray burst extends far beyond its immediate surroundings. The intense radiation emitted during the explosion can strip away the atmospheres of nearby planets, sterilizing them and making life impossible. In NGC 1277, the burst likely had a profound effect on its galactic neighborhood, altering the chemistry of interstellar gas and influencing the formation of stars and planetary systems. It's a stark reminder of how interconnected and dynamic the universe truly is. Studying this remnant provides valuable insights into the life cycles of stars and the forces that drive galactic evolution. By analyzing its composition and structure, scientists can piece together the story of the star that once existed and the explosive end it met. It also helps us understand the broader implications of gamma-ray bursts, which, while rare, play a crucial role in shaping the cosmos. As we continue to explore NGC 1277, the gamma-ray burst remnant stands as a testament to the incredible power and unpredictability of the universe. It's a reminder that even in the vastness of space, events of unimaginable scale can leave lasting marks, influencing the destiny of entire galaxies. Next, we'll delve into another remarkable feature of NGC 1277, a binary black hole system where two supermassive black holes orbit each other in a cosmic dance. Stay tuned as we uncover the mysteries of this extraordinary pairing. Now, let's turn our attention to one of the most intriguing phenomena in NGC 1277, a binary black hole system. Imagine two supermassive black holes, each with a gravitational pull so immense that not even light can escape, locked in a cosmic dance as they orbit each other. This rare and fascinating pairing offers a glimpse into the extreme forces at play in the universe. Binary black hole systems like this one typically form when two galaxies collide and merge. As the galaxies come together, their central black holes are drawn toward each other, eventually spiraling into a shared orbit. In the case of NGC 1277, scientists believe this system originated from a galactic merger billions of years ago. Over time, the black holes have been slowly circling closer, their immense gravity warping the fabric of spacetime around them. One of the most remarkable aspects of this binary system is the gravitational waves it produces. As the black holes orbit each other, they create ripples in spacetime waves that travel outward at the speed of light. These gravitational waves carry energy away from the system, causing the black holes to gradually spiral closer together. Eventually, they will collide in a cataclysmic event, releasing an enormous burst of energy and sending even more powerful gravitational waves across the universe. The detection of gravitational waves from systems like this has revolutionized our understanding of the cosmos. By studying these waves, scientists can learn about the masses, spins, and distances of the black holes involved. In the case of NGC 1277, this binary system provides a unique opportunity to observe the dynamics of supermassive black holes and the role they play in shaping galaxies. But the story doesn't end there. The eventual collision of these black holes will be one of the most energetic events in the universe, releasing energy equivalent to billions of supernovae. Such an event could have profound effects on the surrounding galaxy, potentially triggering the formation of new stars or altering the structure of NGC 1277 itself. As we continue to explore this binary black hole system, we gain not only a deeper understanding of black hole physics, but also a greater appreciation for the dynamic and ever-changing nature of the universe. Next, we'll venture into another mysterious region of NGC 1277, a void where dark energy appears to dominate, challenging our understanding of the forces that govern the cosmos. Stay with us as we uncover the secrets of this enigmatic space. Now, let's shift our focus to one of the most puzzling regions in NGC 1277, a void where dark energy seems to hold sway. This mysterious expanse challenges our understanding of the forces that shape the universe, offering a glimpse into the enigmatic nature of dark energy itself. Unlike the crowded regions of stars and galaxies, this void is a vast, nearly empty space where dark energy's influence becomes strikingly apparent. Dark energy, the mysterious force driving the accelerated expansion of the universe, is thought to dominate in such voids. In this region of NGC 1277, its effects are magnified, creating a space where the usual rules of gravity and matter seem to take a backseat. Instead of being pulled together by gravity, galaxies and other structures on the edges of this void are pushed apart, as if the void itself is expanding outward. This phenomenon provides a unique laboratory for studying dark energy's behavior on a smaller, more observable scale. One of the most fascinating aspects of this dark energy void is its impact on the surrounding galaxy. As dark energy exerts its influence, it can alter the trajectories of nearby stars and gas clouds, subtly reshaping the structure of NGC 1277 over time. This process is slow and gradual, but over billions of years, it could lead to significant changes in the galaxy's overall form and composition. Scientists are particularly interested in how this void interacts with the galaxy's dark matter halo, as the interplay between dark energy and dark matter remains one of the greatest mysteries in modern astrophysics. The presence of this void also raises intriguing questions about the nature of dark energy itself. Is it a constant force, or does its strength vary across different regions of the universe? By studying voids like this one in NGC 1277, researchers hope to uncover clues that could help answer these questions. Observations of how light bends and travels through the void, for example, can provide insights into the distribution and behavior of dark energy. As we explore this dark energy void, we're reminded of how much we still have to learn about the universe. It's a humbling reminder that even in the vastness of space, there are regions where the rules we think we understand no longer apply. Next, we'll journey to another strange corner of NGC 1277, a comet traveling from another star system, bringing with it secrets from distant reaches of the cosmos. Stay with us as we uncover the story of this interstellar wanderer. Now, let's turn our attention to a cosmic traveler unlike any other, an interstellar comet making its way through NGC 1277. This remarkable object didn't originate within our galaxy or even within NGC 1277 itself. Instead, it's a visitor from another star system, carrying with it secrets from the far reaches of the cosmos. Its journey across the vast expanse of space brings it into the heart of this mysterious galaxy, offering scientists a rare opportunity to study an object that has traveled unimaginable distances. The trajectory of this interstellar comet is one of its most intriguing features. Unlike comets that orbit within a single star system, this one follows a path that suggests it was ejected from its original home by a powerful gravitational event, such as a close encounter with a massive planet or even a passing star. As it hurtles through NGC 1277, its speed and direction provide clues about its origins and the forces that set it on this incredible journey. By tracking its movement, astronomers can piece together the story of its past and predict where it might be headed next. What makes this comet even more fascinating is its composition. Unlike typical comets found within our solar system, which are primarily made of ice, dust, and organic compounds, this interstellar visitor contains elements and molecules that are rare or even absent in our own cosmic neighborhood. Scientists have detected traces of exotic materials that hint at the unique conditions of its birthplace, offering a glimpse into the chemistry of distant star systems. These findings could help us better understand how planets and other celestial bodies form in different parts of the universe. The presence of this interstellar comet in NGC 1277 also raises questions about how common such visitors might be. Could there be more of these cosmic wanderers drifting through the galaxy, unnoticed until now? Each discovery of an interstellar object like this one brings us closer to answering that question, shedding light on the dynamic and interconnected nature of the universe. As we follow the path of this interstellar comet, we're reminded of the vastness of space and the countless mysteries it holds. Its journey through NGC 1277 is a testament to the incredible forces at work in the cosmos, and a reminder that even the smallest objects can carry profound insight. Next, we'll explore another extraordinary feature of this galaxy, a galactic fountain where gas is ejected and then falls back in a breathtaking cosmic cycle. Stay with us as we uncover the secrets of this mesmerizing phenomenon. Now, shifting our gaze to another marvel within NGC 1277, we encounter a phenomenon that seems almost poetic in its motion, a galactic fountain. Picture this: vast streams of gas being ejected from the heart of the galaxy, soaring outward into the void, only to be pulled back in by the galaxy's immense gravitational pull. This breathtaking cycle of ejection and return is not just a cosmic spectacle, it's a vital process that shapes the very fabric of NGC 1277. The galactic fountain begins its journey in the galaxy's core, where intense energy from stars, supernova, and even the supermassive black hole propels gas outward at incredible speeds. This gas, often heated to extreme temperatures, travels far beyond the galaxy's visible boundaries, creating a halo of material that surrounds NGC 1277. But the story doesn't end there. Over time, gravity takes hold, pulling the gas back down in a slow, majestic arc, much like water cascading back into a fountain's basin. This process plays a crucial role in regulating the galaxy's evolution. As the gas is ejected, it carries away energy and heavy elements forged in the hearts of stars. When it falls back, it enriches the galaxy with these materials, fueling the birth of new stars and planets. Without this cycle, NGC 1277 might look very different today. Its star formation could stall, and its structure could become unstable. The galactic fountain, then, is not just a beautiful phenomenon, it's a lifeline for the galaxy. What makes this fountain even more intriguing is its connection to the galaxy's supermassive black hole. Some scientists believe that the black hole's immense energy output helps drive the ejection of gas, creating a feedback loop that sustains the fountain over billions of years. This interplay between the black hole and the galactic fountain highlights the delicate balance of forces that govern the life of a galaxy. As we marvel at this cosmic fountain, we're reminded of the intricate processes that shape the universe. It's a reminder that even in the vastness of space, there's a rhythm, a cycle of creation and renewal that echoes across the cosmos. Next, we'll turn our attention to a region in NGC 1277 where the very fabric of reality seems to twist and warp, a place where quantum fluctuations become visible to the keen eye of science. Stay with us as we dive into this mind-bending phenomenon. Now, let's venture into one of the most mind-bending corners of NGC 1277, a region where the very rules of physics seem to blur. Here, in this peculiar zone, quantum fluctuations become visible, offering scientists a rare glimpse into the subatomic world on a cosmic scale. Imagine a place where particles pop in and out of existence, where the fabric of reality itself flickers like a candle in the wind. This is the realm of quantum fluctuations, and it's as fascinating as it is mysterious. Quantum fluctuations are tiny, random changes in energy that occur at the smallest scales of the universe. Normally, these fluctuations are so minuscule that they're impossible to observe directly. But in this region of NGC 1277, something extraordinary happens. The conditions are just right: extreme gravitational forces, intense radiation, and a unique interplay of energy to amplify these fluctuations, making them detectable to our most advanced instruments. It's like catching a whisper in a storm, a fleeting moment where the universe reveals its deepest secrets. What makes this discovery so groundbreaking is its implications for our understanding of physics. Quantum fluctuations are a cornerstone of quantum mechanics, the branch of science that explains how particles behave at the tiniest scales. By observing them in such a dramatic setting, scientists can test theories about the nature of reality itself. For instance, these fluctuations might hold clues about the early universe, when everything was compressed into an unimaginably small space. They could even shed light on the mysterious forces that govern dark energy and dark matter, two of the greatest puzzles in modern cosmology. But the implications don't stop there. Some researchers believe that quantum fluctuations could play a role in the formation of galaxies, including NGC 1277. These tiny ripples in spacetime might have acted as seeds, triggering the collapse of matter into the vast structures we see today. If true, it would mean that the very fabric of the universe is shaped by processes so small they're almost beyond comprehension. As we explore this quantum frontier, we're reminded of how much we still have to learn about the cosmos. NGC 1277, with its strange and wondrous objects, continues to challenge our understanding and push the boundaries of science. Next, we'll turn our attention to an object that has sparked both curiosity and controversy, a mysterious structure that some believe could be an ancient alien artifact. Stay with us as we unravel this cosmic enigma. Now, shifting our gaze to another corner of NGC 1277, we encounter an object that has sparked both fascination and debate among astronomers and enthusiasts alike, a mysterious structure that some speculate could be an ancient alien artifact. This enigmatic object, unlike anything else in the galaxy, has raised questions about its origins and purpose, challenging our understanding of what might exist beyond our own world. The artifact, as it's often referred to, appears to be a massive, intricately designed structure with geometric patterns that defy natural explanations. Its surface is marked by what seem to be deliberate formations, symmetrical shapes, precise angles, and what some interpret as possible inscriptions or symbols. These features have led some researchers to propose that this object could be the work of an advanced extraterrestrial civilization, perhaps a relic left behind by beings who once inhabited or visited NGC 1277. Supporters of this theory point to the object's unusual composition and placement. Unlike natural celestial bodies, which are typically shaped by gravitational forces and cosmic collisions, this structure stands out for its apparent artificiality. Its materials, as detected by spectroscopic analysis, include elements not commonly found in the surrounding region, suggesting it may have been constructed or transported from elsewhere. Additionally, its location within the galaxy, far from any known star systems or planetary bodies, adds to the intrigue. Why would such an object be placed in such an isolated spot? Could it be a marker, a monument, or even a piece of technology left behind by an ancient alien race? However, not everyone is convinced. Skeptics argue that while the object is undeniably strange, there's no definitive proof that it's artificial. They suggest that natural processes such as rare cosmic events or unknown geological phenomena could account for its peculiar features. For instance, the geometric patterns might be the result of extreme pressure and heat acting on the object's surface over billions of years. Similarly, the unusual composition could be explained by a unique stellar explosion or the remnants of a long-dead star. Without direct evidence of alien involvement, they caution against jumping to conclusions. The debate over this object highlights the challenges of interpreting distant cosmic phenomena. While the idea of an ancient alien artifact is undeniably thrilling, it's also a reminder of how much we still don't know about the universe. NGC 1277, with its array of strange and wondrous objects, continues to push the boundaries of our imagination and scientific understanding. As we ponder the possibilities, we're left with more questions than answers, questions that drive us to keep exploring, keep questioning, and keep searching for the truth. Next, we'll turn our attention to another peculiar feature of NGC 1277, a galaxy within the galaxy that appears to have no stars at all. What could explain such a bizarre phenomenon? Join us as we delve into this cosmic mystery. Now, let's journey deeper into the mysteries of NGC 1277 to uncover one of its most baffling features, a galaxy that seems to defy everything we know about galaxies. Imagine a galaxy without stars, no shimmering lights, no glowing clusters, just an expanse of darkness. This is the starless galaxy, a cosmic anomaly that challenges our understanding of how galaxies form and evolve. At first glance, the idea of a starless galaxy seems impossible. After all, galaxies are defined by their stars, billions of them swirling together in vast, luminous structures. But this particular galaxy within NGC 1277 appears to be an exception. Observations reveal a massive collection of gas and dust, yet no detectable stars. How can such a thing exist? One theory suggests that this galaxy might be in a very early stage of formation. Galaxies begin as clouds of gas and dust, gradually collapsing under gravity to form stars. Perhaps this starless galaxy is a cosmic baby, still in the process of gathering the materials it needs to ignite its first stars. If this is the case, it offers astronomers a rare glimpse into the earliest moments of galactic evolution, a snapshot of what our own Milky Way might have looked like billions of years ago. Another possibility is that this galaxy has somehow lost its stars. Catastrophic events such as collisions with other galaxies or the gravitational influence of a nearby supermassive black hole could have stripped away its stellar population. The stars might have been flung out into intergalactic space, leaving behind a ghostly remnant of gas and dust. This scenario would make the starless galaxy a cosmic graveyard, a silent witness to the violent forces that shape the universe. There's also the intriguing idea that this galaxy might be dominated by dark matter. Dark matter, which doesn't emit light or interact with electromagnetic forces, could be holding the galaxy together without the need for stars. In this case, the starless galaxy would be a dark matter halo, invisible to traditional telescopes but detectable through its gravitational effects on surrounding objects. This would make it a unique laboratory for studying the mysterious substance that makes up most of the universe's mass. The existence of a starless galaxy raises profound questions about the diversity of cosmic structures. It reminds us that the universe is full of surprises, constantly challenging our assumptions and expanding our knowledge. As we continue to study NGC 1277, this enigmatic galaxy serves as a reminder of how much we still have to learn about the cosmos. Next, we'll explore another extraordinary feature of NGC 1277, a natural cosmic ray accelerator, where particles reach energies beyond anything we can produce on Earth. What powers this incredible phenomenon? Stay with us as we uncover the secrets of this cosmic powerhouse. Now, let's turn our attention to one of the most energetic phenomena in NGC 1277, a natural cosmic ray accelerator. This cosmic powerhouse is a region where particles are accelerated to unimaginable speeds, reaching energies far beyond anything we can create in laboratories here on Earth. But what exactly powers this incredible process, and how does it work? Cosmic rays are high-energy particles, mostly protons and atomic nuclei, that travel through space at nearly the speed of light. They are thought to originate from some of the most violent events in the universe, such as supernova explosions or the jets of supermassive black holes. In NGC 1277, scientists have identified a region where these particles are being accelerated to extraordinary levels, creating a natural cosmic ray accelerator. One of the leading theories suggests that this acceleration is driven by shock waves. These shock waves can form in the aftermath of massive stellar explosions or during the collision of galaxies. As particles encounter these shock waves, they gain energy, much like a surfer catching a wave. Over time, this process can propel particles to incredibly high speeds, turning them into cosmic rays. Another possibility is that magnetic fields play a key role. In regions with strong magnetic fields, particles can spiral along the field lines, gaining energy as they move. This process, known as magnetic reconnection, can accelerate particles to extreme velocities. In NGC 1277, the presence of a supermassive black hole and its powerful jets could create the perfect conditions for this kind of acceleration. The cosmic ray accelerator in NGC 1277 is not just a fascinating phenomenon, it's also a valuable tool for scientists. By studying these high-energy particles, researchers can learn more about the processes that shape galaxies and the universe itself. Cosmic rays can reveal information about the magnetic fields, shock waves, and other forces at work in distant galaxies, providing insights that are impossible to gather from light alone. But the story doesn't end there. These high-energy particles also have a profound impact on their surroundings. When cosmic rays collide with gas and dust, they can trigger the formation of new stars and even influence the chemistry of interstellar space. In this way, the cosmic ray accelerator in NGC 1277 is not just a source of energy, it's a driver of cosmic evolution. As we continue to explore NGC 1277, this natural particle accelerator reminds us of the incredible forces at work in the universe. It's a testament to the power of nature and the endless mysteries waiting to be uncovered. Next, we'll dive into another astonishing feature of this galaxy, a swirling vortex of gas and dust known as the galactic tornado. What secrets does this cosmic storm hold? Stay with us as we unravel its mysteries. Now, let's shift our gaze to one of the most mind-bending phenomena in NGC 1277, a galactic mirage. Imagine looking at a distant object in space, only to see it distorted, duplicated, or even appearing in multiple places at once. This is the power of a galactic mirage, where light itself is bent and twisted by the immense gravitational forces at play. At the heart of this phenomenon lies a concept known as gravitational lensing. When a massive object like a galaxy or a cluster of galaxies lies between us and a more distant light source, its gravity can warp the fabric of spacetime. This warping acts like a giant cosmic lens, bending the path of light as it travels toward us. In NGC 1277, astronomers have observed this effect in action, creating stunning visual distortions that challenge our understanding of space and light. But how does this work? Think of spacetime as a stretched-out sheet. When a heavy object like a galaxy sits on this sheet, it creates a deep curve. Light traveling near this curve doesn't move in a straight line, it follows the curve, bending around the massive object. Depending on the alignment of the objects, this can result in multiple images of the same distant source, or even a ring-like structure known as an Einstein ring. In NGC 1277, these mirages provide a unique window into the distribution of mass within the galaxy, including its dark matter content. Gravitational lensing isn't just a cosmic curiosity, it's a powerful tool for astronomers. By studying these mirages, scientists can map the distribution of dark matter, measure the expansion rate of the universe, and even discover distant galaxies that would otherwise be too faint to see. In NGC 1277, the galactic mirage has revealed hidden details about the galaxy's structure and the mysterious forces shaping it. What makes this phenomenon even more fascinating is its ability to magnify distant objects. Just like a magnifying glass, gravitational lensing can amplify the light from faraway galaxies, allowing us to peer deeper into the universe than ever before. In NGC 1277, this has led to the discovery of ancient galaxies and other cosmic treasures that would have remained hidden without the help of this natural telescope. As we marvel at the galactic mirage in NGC 1277, we're reminded of the intricate interplay between light, gravity, and spacetime. It's a phenomenon that not only captivates the imagination but also deepens our understanding of the universe. Next, we'll explore another extraordinary feature of this galaxy, a theoretical interdimensional portal. What could such a portal reveal about the nature of reality? Stay with us as we venture into the unknown. Now, let's take a step into the realm of the truly extraordinary, a theoretical interdimensional portal in NGC 1277. This concept pushes the boundaries of our understanding of the universe, blending science with the kind of speculative ideas that fuel both curiosity and debate. What if, hidden within this galaxy, there exists a gateway to another dimension? What could such a portal reveal about the nature of reality itself? The idea of an interdimensional portal is rooted in theoretical physics, particularly in concepts like wormholes and higher dimensions. A wormhole, often described as a tunnel through space-time, could theoretically connect two distant points in the universe, or even two entirely different universes. In NGC 1277, some scientists speculate that the extreme gravitational forces and the presence of dark matter might create conditions where such a portal could exist. While this remains purely theoretical, the implications are staggering. Could this portal allow for faster-than-light travel, or might it offer a glimpse into parallel realities? One of the biggest challenges in exploring this idea is the lack of direct evidence. Interdimensional portals, if they exist, would likely be incredibly unstable or exist on scales too small to detect with current technology. Even if we could find one, the energy required to stabilize or traverse it would be beyond anything humanity has ever harnessed. Yet, the possibility alone opens up fascinating questions about the nature of spacetime and the limits of our scientific knowledge. Another intriguing aspect is the role of dark matter and dark energy in this scenario. These mysterious components of the universe, which make up the vast majority of its mass and energy, could play a key role in creating or sustaining such a portal. In NGC 1277, where dark matter is abundant, the conditions might be just right for these theoretical constructs to form. But without a deeper understanding of dark matter, we can only speculate. The concept of an interdimensional portal also raises philosophical questions. If such a gateway exists, what would it mean for our understanding of reality? Could it challenge our perception of time, space, and even existence? While these questions may seem like the stuff of science fiction, they remind us that the universe is far stranger and more complex than we can imagine. As we ponder the possibilities of an interdimensional portal in NGC 1277, we're reminded that the universe is full of mysteries waiting to be uncovered. Whether or not such a portal exists, the pursuit of these ideas drives us to explore, question, and dream. Next, we'll turn our attention to another enigmatic feature of this galaxy, a dark star cluster that defies conventional understanding. What secrets does it hold? Let's find out. Now, shifting our gaze to another cosmic enigma, we encounter the dark star cluster in NGC 1277, a celestial phenomenon that challenges our understanding of how stars form and behave. Unlike typical star clusters that shine brightly with the light of countless stars, this one remains shrouded in darkness, emitting no visible light. It's as if this cluster exists in the shadows of the galaxy, hiding its secrets from plain sight. So, how was such a mysterious object discovered? Astronomers first detected this cluster not through traditional optical telescopes, but by observing its gravitational effects on surrounding matter. The cluster's immense mass bends the light of distant stars and galaxies behind it, a phenomenon known as gravitational lensing. This bending of light revealed the presence of something massive yet invisible, leading scientists to deduce the existence of a dark star cluster. Further observations using radio waves and X-rays confirmed that this cluster is packed with stars, but for reasons still unclear, they emit no visible light. What makes this dark star cluster truly unique is its composition. While most star clusters are dominated by bright, young stars, this one appears to be made up of older, dimmer stars that have long since burned out or evolved into objects like neutron stars or black holes. Some theories suggest that the cluster might be filled with failed stars, known as brown dwarfs, which never ignited fully and remain faint. Others propose that the cluster could be home to a dense population of black holes, invisible to optical telescopes but detectable through their gravitational influence. The discovery of this dark star cluster raises intriguing questions about the life cycle of stars and the diversity of stellar systems in the universe. Why did these stars evolve so differently from those in other clusters? Could this cluster be a relic from an earlier era of the universe, preserving conditions that no longer exist elsewhere? These questions highlight the importance of studying such unusual objects, as they offer clues about the broader processes shaping galaxies. As we continue to explore NGC 1277, the dark star cluster stands as a reminder that the universe is full of surprises, often hiding its most fascinating secrets in the least expected places. Next, we'll delve into another mysterious feature of this galaxy, a phenomenon where light echoes reveal past events, offering a glimpse into the history of NGC 1277. What stories do these echoes tell? Let's find out. Now, let's turn our attention to a phenomenon that feels almost like a cosmic time machine, the galactic echo in NGC 1277. Imagine light traveling across the vast expanse of space, bouncing off interstellar dust and gas, and creating ripples that reveal events from the distant past. This is what astronomers call a light echo, and in NGC 1277, it offers a rare window into the galaxy's history. Light echoes occur when a sudden burst of light, such as from a supernova or a massive stellar explosion, illuminates surrounding clouds of dust and gas. The light scatters off these particles, creating a delayed reflection that can be observed long after the original event has faded. In NGC 1277, these echoes have allowed scientists to piece together dramatic moments in the galaxy's life, such as the explosive deaths of massive stars or the violent interactions between celestial objects. What makes this phenomenon so significant is its ability to act as a cosmic record keeper. By studying the timing, intensity, and patterns of these light echoes, astronomers can reconstruct events that occurred thousands or even millions of years ago. It's like uncovering a hidden chapter in the galaxy's story, one that would otherwise remain lost to time. For instance, a single light echo might reveal the exact moment a star collapsed into a black hole or the aftermath of a collision between two neutron stars. But the galactic echo isn't just about looking backward. It also helps scientists understand the present and future of NGC 1277. By analyzing how light interacts with the galaxy's interstellar medium, researchers can map the distribution of dust and gas, shedding light on how stars and planets form. These echoes also provide clues about the galaxy's structure and dynamics, helping astronomers refine their models of how galaxies evolve over billions of years. The discovery of light echoes in NGC 1277 underscores the importance of patience and precision in astronomy. These faint, delayed signals require advanced instruments and careful observation to detect and interpret. Yet, the effort is well worth it, as each echo brings us closer to understanding the intricate tapestry of the universe. As we move forward in our exploration of NGC 1277, the galactic echo reminds us that the universe is not just a place of space but also of time. Every beam of light carries a story, and every echo is a whisper from the past, urging us to listen closely. Next, we'll venture into another fascinating feature of this galaxy, a massive dust storm that shapes its cosmic landscape in ways you might not expect. What secrets does this storm hold? Let's find out. Now, let's shift our gaze to a phenomenon that transforms the cosmic landscape of NGC 1277, a massive dust storm swirling through its depths. Picture a colossal tempest of gas and dust stretching across vast regions of the galaxy, shaping its environment in ways that are both destructive and creative. This isn't just a storm in the traditional sense. It's a cosmic event that plays a crucial role in the life cycle of stars and planets. The origins of this dust storm can be traced back to the violent interactions within NGC 1277. Collisions between stars, supernova explosions, and the gravitational pull of the galaxy's supermassive black hole all contribute to the creation of these turbulent clouds. As massive stars reach the end of their lives and explode, they eject enormous amounts of dust and gas into space. Over time, these materials accumulate, forming dense clouds that are stirred into motion by the galaxy's dynamic forces. The result is a storm of epic proportions, one that can span thousands of light years. But what makes this dust storm so significant? For one, it acts as a cosmic nursery. Within these swirling clouds, particles of dust and gas collide and clump together, eventually forming the building blocks of new stars and planets. Without these storms, the galaxy would lack the raw materials needed for star formation, leaving its future barren and lifeless. In this way, the dust storm is both a destroyer and a creator, tearing apart old structures while laying the foundation for new ones. The effects of this storm extend far beyond star formation. As it moves through the galaxy, it shapes the interstellar medium, the space between stars. By redistributing dust and gas, the storm influences the temperature and density of these regions, which in turn affects how light travels through the galaxy. This can make certain areas of NGC 1277 appear darker or brighter, depending on the concentration of dust. For astronomers, studying these patterns provides valuable insights into the galaxy's structure and evolution. Yet, the dust storm also poses challenges. Its dense clouds can obscure our view of distant objects, making it difficult to observe the galaxy's inner workings. However, advanced telescopes and instruments have allowed scientists to peer through the storm, revealing hidden details about the processes at play. For instance, they've discovered that the storm's turbulence can trigger the formation of massive stars, which burn brightly but have short lifespans. These stars, in turn, contribute to the storm's intensity, creating a feedback loop that shapes the galaxy over millions of years. As we explore NGC 1277, the cosmic dust storm serves as a reminder of the galaxy's dynamic nature. It's a place of constant change where destruction and creation are intertwined. Next, we'll uncover another intriguing feature of this galaxy, a phantom galaxy that appears and disappears, challenging our understanding of the cosmos. What mysteries does it hold? Let's dive in. Now, let's turn our attention to one of the most baffling mysteries within NGC 1277, a phantom galaxy that seems to flicker in and out of existence. Imagine a galaxy that one moment is clearly visible, and the next it vanishes as if it were never there. This ghostly phenomenon has left astronomers scratching their heads, searching for answers to explain its elusive behavior. The phantom galaxy, as it's often called, isn't a trick of the eye or a glitch in our telescopes. Instead, its appearance and disappearance are tied to the complex interplay of light, gravity, and the galaxy's surroundings. One leading theory suggests that this galaxy is being obscured by massive clouds of dust and gas, similar to the cosmic dust storm we explored earlier. These dense clouds can block the light emitted by the galaxy, making it temporarily invisible to our instruments. When the clouds shift or disperse, the galaxy reappears, creating the illusion of a vanishing act. Another intriguing possibility involves gravitational lensing, a phenomenon where the gravity of a massive object, like a black hole or a cluster of galaxies, bends and distorts the light from objects behind it. In this case, the phantom galaxy might lie behind such a massive object, causing its light to be magnified, warped, or even redirected. Depending on the alignment of these cosmic players, the galaxy could appear bright and clear one moment, then fade into obscurity the next. This cosmic hide and seek adds another layer of mystery to NGC 1277's already enigmatic nature. Some scientists have even proposed that the phantom galaxy could be a result of time dilation, a concept rooted in Einstein's theory of relativity. If the galaxy is moving at an incredibly high speed or is located in a region with intense gravitational forces, time could appear to slow down from our perspective. This might cause the galaxy's light to reach us in irregular bursts, creating the illusion of it appearing and disappearing. While this theory is still speculative, it highlights the extraordinary possibilities that exist within the cosmos. The phantom galaxy also raises questions about the nature of dark matter. Could invisible dark matter structures be influencing the galaxy's visibility? Some researchers believe that clumps of dark matter might be acting as cosmic lenses, bending light in unpredictable ways and contributing to the galaxy's ghostly behavior. If true, this would provide valuable clues about the distribution and properties of dark matter, one of the universe's greatest mysteries. As we continue to study this phantom galaxy, one thing is clear: it challenges our understanding of how galaxies behave and interact. Its elusive nature reminds us that the universe is full of surprises, and even the most advanced technology can't always reveal its secrets. Next, we'll explore another fascinating feature of NGC 1277, a powerful jet emitted by a black hole, shaping the galaxy in ways that defy imagination. What forces drive this cosmic engine? Let's find out. Now, shifting our focus to another awe-inspiring feature of NGC 1277, we encounter a phenomenon that showcases the raw power of the cosmos, a black hole jet. This isn't just any jet, it's a colossal stream of energy and matter, shooting out from the vicinity of a supermassive black hole at nearly the speed of light. These jets are among the most energetic events in the universe, and the one in NGC 1277 is no exception. But how does something so extraordinary come to be? At the heart of this phenomenon lies the supermassive black hole itself. As matter spirals toward the black hole, it doesn't just vanish into oblivion. Instead, some of it gets funneled into powerful magnetic fields which act like cosmic particle accelerators. These fields channel the material into narrow beams, launching it outward in opposite directions. The result is a pair of jets that can stretch for thousands of light years, far beyond the boundaries of the galaxy itself. What makes these jets so fascinating is their sheer power. They carry enough energy to heat up the surrounding gas, trigger star formation, and even halt the growth of entire galaxies. In NGC 1277, the black hole jet has carved out vast cavities in the surrounding gas, creating a dynamic and ever-changing environment. These jets also emit intense radiation, from radio waves to X-rays, making them visible across vast distances. But the impact of these jets goes beyond just their immediate surroundings. They play a crucial role in shaping the galaxy's evolution. By redistributing energy and matter, they influence how stars form and how galaxies grow over billions of years. In some cases, they can even prevent galaxies from becoming too massive by blowing away the gas needed for star formation. This delicate balance between creation and destruction is one of the many ways black holes shape the universe. The black hole jet in NGC 1277 also offers a glimpse into the extreme physics at play near these cosmic giants. The conditions near the black hole are so intense that they challenge our understanding of how matter and energy behave under such extreme pressures and temperatures. Studying these jets helps scientists test theories about gravity, magnetism, and the behavior of matter in ways that are impossible to replicate on Earth. As we marvel at the black hole jet's power and beauty, it's worth remembering that this is just one of the many wonders NGC 1277 has to offer. Next, we'll uncover another relic of the early universe, a fossilized galaxy that holds secrets about the cosmos's infancy. What can this ancient structure tell us about the universe's origins? Let's dive in. Now, let's turn our attention to a remarkable relic hidden within NGC 1277, a fossilized galaxy. This ancient structure is like a time capsule, preserving the conditions of the early universe and offering us a rare glimpse into the cosmos's infancy. Imagine a galaxy so old that it has remained virtually unchanged for billions of years, untouched by the chaotic processes that shape younger galaxies. This is what we're dealing with here, a galactic fossil that holds secrets about how the universe evolved. The fossilized galaxy in NGC 1277 is estimated to be over 10 billion years old, making it one of the oldest structures we've ever observed. To put that into perspective, this galaxy formed when the universe itself was still in its youth, just a few billion years after the Big Bang. Its age alone makes it a treasure trove of information, but what truly sets it apart is its pristine state. Unlike most galaxies, which have undergone countless collisions, mergers, and star-forming events, this fossilized galaxy has remained largely undisturbed. It's like finding a perfectly preserved artifact from a bygone era. So, what can this ancient galaxy tell us about the early universe? For starters, its composition provides clues about the types of stars and elements that existed back then. The stars within this fossilized galaxy are predominantly old and metal-poor, meaning they contain fewer heavy elements like iron and carbon compared to younger stars. This suggests that they formed during a time when the universe was still relatively simple, before generations of stars had produced and scattered these heavier elements through supernova. Additionally, the fossilized galaxy's structure offers insights into how galaxies formed and evolved in the early universe. Its compact size and lack of recent star formation indicate that it may represent an early stage of galactic development before the processes of accretion and merging became widespread. By studying this galaxy, scientists can piece together how the first galaxies grew and how they contributed to the large-scale structure of the universe we see today. But the significance of this galactic fossil goes even further. It challenges our understanding of how galaxies age and evolve. Most galaxies, including our own Milky Way, have undergone significant changes over billions of years, but this fossilized galaxy has remained frozen in time. Why did it escape the usual processes of galactic evolution? Was it simply isolated from other galaxies, or are there other factors at play? These are questions that astronomers are still working to answer. As we marvel at this ancient relic, it's worth reflecting on what it represents. The fossilized galaxy in NGC 1277 is more than just a curiosity. It's a window into the universe's distant past, offering us a chance to study the conditions that shape the cosmos as we know it. And as we continue to explore NGC 1277, we'll uncover even more wonders that challenge our understanding of the universe. Next, we'll journey to a pulsar that acts like a cosmic lighthouse, guiding us through the mysteries of space. What makes this pulsar so unique? Let's find out. Now, shifting our gaze to another marvel within NGC 1277, we encounter a pulsar that serves as a cosmic lighthouse, cutting through the darkness of space with its rhythmic beams of light. Pulsars are among the most fascinating objects in the universe, and this one is no exception. Imagine a rapidly spinning neutron star, the dense remnant of a massive star that exploded in a supernova. As it spins, it emits beams of radiation from its magnetic poles, sweeping across space like the beam of a lighthouse. When these beams point toward Earth, we detect them as regular pulses of light, hence the name pulsar. This particular pulsar in NGC 1277 is extraordinary not just for its precision, but also for its role as a navigational beacon in the cosmos. Its pulses are so consistent that they rival the accuracy of atomic clocks here on Earth. This makes it an invaluable tool for astronomers who use its signals to measure distances, study the properties of interstellar space, and even test the predictions of Einstein's theory of general relativity. The pulsar's regularity allows scientists to detect tiny changes in its timing, which can reveal the presence of orbiting planets, gravitational waves, or other cosmic phenomena. But what truly sets this pulsar apart is its environment. Located within NGC 1277, it offers a unique opportunity to study how pulsars behave in a galaxy dominated by a supermassive black hole and surrounded by a mysterious dark matter halo. The intense gravitational forces and magnetic fields in this region could be influencing the pulsar's behavior in ways we're only beginning to understand. For instance, its pulses might be affected by the warping of spacetime near the black hole or by interactions with the dark matter halo. These effects could provide new insights into the nature of gravity, dark matter, and the extreme conditions found in galaxies like NGC 1277. Beyond its scientific value, this pulsar also captures the imagination. Its rhythmic pulses are a reminder of the universe's inherent order, even amidst the chaos of exploding stars and colliding galaxies. It's a cosmic metronome ticking away with unerring precision, guiding us through the vastness of space. And as we continue to study it, we may uncover even more about the forces that shape our universe. With this cosmic lighthouse illuminating the mysteries of NGC 1277, we now turn our attention to another intriguing object, a massive chunk of ice drifting through the galaxy. What secrets does this interstellar iceberg hold? Let's find out. Now, let's turn our attention to something truly out of the ordinary, a massive chunk of ice drifting through the vast expanse of NGC 1277. This interstellar iceberg, as it's often called, is a frozen relic from the early days of the galaxy, carrying secrets from a time long before our solar system even existed. Unlike the icy bodies we're familiar with in our own cosmic neighborhood, this one is far larger and far more mysterious. The origins of this interstellar iceberg are as fascinating as they are elusive. Scientists believe it likely formed in the cold, dense regions of interstellar space, where temperatures are so low that molecules of water and other volatile compounds freeze solid. Over billions of years, these frozen particles clumped together, growing into a massive structure that now drifts through the galaxy. Some theories suggest it could have been ejected from a distant star system during a violent cosmic event, such as a supernova or a planetary collision, sending it on a journey across the galaxy. What makes this iceberg particularly intriguing is its composition. While it's primarily made of water ice, it also contains traces of other frozen gases such as methane, ammonia, and carbon dioxide. These compounds are like cosmic time capsules, preserving the chemical conditions of the environment in which they formed. By studying them, scientists can gain insights into the early stages of galaxy formation and the processes that shape the building blocks of planets and stars. But the real mystery lies in how this iceberg has managed to survive for so long. In the harsh environment of space, exposed to radiation and the gravitational pull of nearby stars and black holes, most icy bodies would have evaporated or been torn apart. Yet this one endures, a testament to the resilience of cosmic materials. Its survival raises questions about the conditions in NGC 1277 and whether similar objects might exist in other galaxies. As we continue to study this interstellar iceberg, we may uncover clues about the origins of water and other essential ingredients for life in the universe. Could such objects have delivered water to young planets, seeding them with the potential for life? Or do they represent a different kind of cosmic process altogether? For now, this frozen wanderer remains a tantalizing puzzle, reminding us that even in the vastness of space, the smallest details can hold the biggest secrets. With this icy enigma drifting through NGC 1277, we now prepare to explore another extraordinary phenomenon, a swirling vortex of gas and dust known as the galactic tornado. What forces shape this cosmic storm, and what can it teach us about the dynamics of galaxies? Let's dive in. Now, let's shift our gaze to one of the most dynamic and visually stunning phenomena in NGC 1277, a colossal swirling vortex of gas and dust known as the galactic tornado. This cosmic storm is not just a breathtaking spectacle, it's a powerful force that shapes the very fabric of the galaxy. Imagine a whirlwind so vast it could engulf entire star systems, churning with energy and leaving a trail of creation and destruction in its wake. The formation of this galactic tornado is a story of chaos and beauty intertwined. It begins with the gravitational interactions between massive objects such as black holes, neutron stars, and even entire galaxies. These interactions can create shock waves that ripple through the surrounding gas and dust, setting off a chain reaction of motion. As the material begins to spin, it's pulled into a spiral, much like water swirling down a drain. Over time, this spiral intensifies, forming a vortex that can stretch across thousands of light years. What makes this tornado particularly fascinating is its role in the life cycle of stars. As the vortex churns, it compresses the gas and dust within it, creating dense pockets of material. These pockets are the birthplaces of new stars, ignited by the immense pressure and heat generated by the swirling motion. In this way, the galactic tornado acts as a cosmic nursery, fostering the creation of stellar systems that will one day light up the galaxy. But the effects of this tornado aren't limited to star formation. The intense forces at play can also tear apart existing structures, shredding gas clouds and even disrupting the orbits of nearby stars. This duality, creation and destruction, makes the galactic tornado a key player in the evolution of NGC 1277. It's a reminder that even in the vastness of space, change is constant, and the forces that shape the universe are as powerful as they are unpredictable. Scientists are particularly interested in studying the magnetic fields within these vortices. The swirling motion generates incredibly strong magnetic fields, which can accelerate particles to near light speeds, producing bursts of radiation that can be detected across the galaxy. These magnetic fields also play a crucial role in shaping the structure of the tornado, influencing how it moves and evolves over time. As we continue to unravel the mysteries of this galactic tornado, we gain deeper insights into the processes that drive the formation and evolution of galaxies. What other secrets might this swirling vortex hold? Could it reveal clues about the origins of cosmic structures or even the nature of dark matter? For now, this cosmic storm remains a mesmerizing enigma, a testament to the dynamic and ever-changing nature of the universe. With a galactic tornado spinning through NGC 1277, we now turn our attention to another intriguing anomaly, a region where dark matter behaves in ways that defy our current understanding. What could be causing this strange phenomenon, and what does it mean for our knowledge of the cosmos? Let's explore further. Now, let's venture into one of the most puzzling regions of NGC 1277, a place where dark matter doesn't behave as we expect it to. This dark matter anomaly challenges our current understanding of one of the universe's most mysterious components. Dark matter, which makes up about 85% of the universe's total mass, is invisible and doesn't interact with light, yet its gravitational effects are undeniable. But here, in this peculiar region of NGC 1277, something strange is happening. Typically, dark matter forms a kind of cosmic scaffold, holding galaxies together and influencing their rotation. However, in this anomaly, dark matter seems to be distributed unevenly, creating pockets where its gravitational pull is either stronger or weaker than predicted. This irregularity has left scientists scratching their heads. Could it be the result of an unseen interaction with another force? Or is there something fundamentally different about dark matter in this part of the galaxy? One leading theory suggests that this anomaly might be caused by the presence of an unknown type of dark matter particle. Unlike the standard model of dark matter, which assumes it's made of weakly interacting massive particles, this new type could have unique properties that cause it to clump or disperse in unexpected ways. Another possibility is that the anomaly is the result of a past cosmic event, such as a collision with another galaxy, which disrupted the normal distribution of dark matter. The implications of this discovery are profound. If dark matter can behave in ways that defy our current models, it could mean that our understanding of the universe's structure is incomplete. This anomaly might hold the key to unlocking new physics, potentially leading to breakthroughs in our knowledge of gravity, particle physics, and even the nature of the cosmos itself. It's a reminder that even the most well-established theories can be challenged by the mysteries of space. As researchers continue to study this region, they hope to uncover more clues about what's causing this unusual behavior. Could this anomaly reveal new insights into the elusive nature of dark matter, or might it point to an entirely new framework for understanding the universe? For now, this dark matter anomaly remains a tantalizing puzzle, one that invites us to rethink what we know about the invisible forces shaping our galaxy. With this mysterious region still holding many secrets, we now turn our attention to another fascinating feature of NGC 1277, a cosmic mirror that reflects light in ways that defy expectations. What could this phenomenon reveal about the nature of light and space? Let's find out. Now, shifting our gaze to another extraordinary feature of NGC 1277, we encounter a phenomenon that seems to bend the rules of light itself, the cosmic mirror. Imagine looking into a vast, celestial-looking glass, where light doesn't just travel in straight lines, but is reflected in ways that create stunning mirror images of distant objects. This cosmic mirror isn't made of glass or polished metal, but rather, it's the result of a fascinating interplay between gravity and light. At the heart of this phenomenon lies a concept known as gravitational lensing. When light from a distant star or galaxy passes near a massive object, like a cluster of galaxies or a black hole, the immense gravitational pull of that object bends the light's path. In the case of NGC 1277, this bending creates a mirror-like effect, where light is redirected to form a duplicate or distorted image of the original source. It's as if the galaxy itself is holding up a mirror to the universe, reflecting its own light and the light of objects far beyond it. What makes this cosmic mirror so intriguing is its ability to magnify and distort the images it reflects. Sometimes the mirror effect can create multiple copies of the same object, arranged in a ring-like pattern known as an Einstein ring. Other times, it stretches and warps the light, producing surreal, elongated shapes that challenge our perception of space and distance. These distortions aren't just visually striking, they also provide astronomers with valuable information about the mass and distribution of the objects causing the lensing effect. The science behind this phenomenon is rooted in Einstein's theory of general relativity, which describes how massive objects warp the fabric of spacetime. When light travels through this warped spacetime, it follows the curves created by gravity, much like a marble rolling along a bent surface. In NGC 1277, the cosmic mirror serves as a natural laboratory for testing these principles, offering a glimpse into the intricate dance between light and gravity. But the cosmic mirror isn't just a scientific curiosity, it's also a powerful tool for discovery. By studying the reflections and distortions it creates, astronomers can peer deeper into the universe than ever before, uncovering hidden galaxies and ancient stars that would otherwise remain invisible. It's like having a telescope built into the fabric of space itself, one that reveals the universe's secrets in ways we're only beginning to understand. As we marvel at this celestial mirror, we're reminded of the countless wonders that NGC 1277 holds. From dark matter anomalies to cosmic reflections, this galaxy continues to challenge and inspire us, offering new insights into the mysteries of the cosmos. And with each discovery, we take another step closer to unraveling the grand tapestry of the universe. Next, we'll explore another enigmatic feature of NGC 1277, a region that acts as a time capsule, preserving conditions from the early universe. What secrets might it hold? Let's find out. Now, let's turn our attention to a remarkable region within NGC 1277 that acts as a window into the distant past, the galactic time capsule. This extraordinary area is like a snapshot frozen in time, preserving conditions that date back to the early universe. For astronomers, it's a treasure trove of information, offering a rare glimpse into how the cosmos looked and behaved billions of years ago. What makes this region so special is its ability to retain ancient gases, dust, and even the faint echoes of early star formation. These elements have remained relatively unchanged, shielded from the chaotic forces that typically reshape galaxies over time. It's as if NGC 1277 has tucked away a piece of the universe's infancy, keeping it safe for us to study today. This preservation allows scientists to analyze the chemical composition and physical properties of the early universe with unprecedented clarity. One of the most fascinating aspects of this galactic time capsule is its role in helping us understand the formation of the first stars and galaxies. By studying the gases and dust here, astronomers can piece together how these primordial materials coalesced to ignite the first bursts of starlight. This region also provides clues about the universe's initial expansion and the conditions that set the stage for the cosmic structures we see today. It's like having a time machine that takes us back to the universe's earliest moments. But the significance of this time capsule goes beyond just understanding the past. It also helps scientists refine their models of how galaxies evolve. By comparing the preserved conditions in NGC 1277 with those in younger galaxies, researchers can track the changes that occur over billions of years. This comparison sheds light on the processes that drive galaxy growth, star formation, and even the distribution of dark matter. In many ways, this region serves as a benchmark, helping us measure how far the universe has come. What's truly awe-inspiring is the sheer scale of time this galactic time capsule represents. The light we observe from this region has traveled for billions of years to reach us, carrying with it the secrets of a universe in its infancy. Every observation made here is a step closer to answering some of the most profound questions in astronomy. How did the universe begin, and how did it grow into the vast, intricate web of galaxies we see today? As we explore this ancient relic within NGC 1277, we're reminded of the galaxy's role as a cosmic storyteller. It doesn't just hold mysteries, it preserves the very history of the universe itself. And with each discovery, we gain a deeper appreciation for the delicate balance of forces that shaped everything we know. Next, we'll venture into a region of NGC 1277 where the universe puts on a dazzling display, a place where stars are born in a spectacular burst of interstellar fireworks. What wonders await us there? Let's find out. Now, let's shift our gaze to one of the most breathtaking sights in NGC 1277, a region where the universe puts on a dazzling show of interstellar fireworks. This area is a stellar nursery, a place where new stars are born in a spectacular burst of light and energy. Imagine a cosmic fireworks display, but on a scale so vast it defies imagination. Here, clouds of gas and dust collapse under their own gravity, igniting the birth of stars in a process that is both violent and beautiful. The beauty of this region lies in its chaotic yet harmonious nature. As massive clouds of hydrogen gas come together, they heat up and begin to glow, creating vibrant hues of red, blue, and gold. These colors are not just for show, they tell us about the temperature and composition of the gas. The hotter regions emit blue light, while cooler areas glow red, painting a vivid picture of the star-forming process. It's a cosmic dance of creation, where every burst of light marks the beginning of a new star. But what makes this stellar nursery truly remarkable is the sheer energy involved. When a star is born, it releases an enormous amount of energy, heating the surrounding gas and triggering a chain reaction of star formation. This process, known as feedback, can create shock waves that ripple through the galaxy, compressing nearby gas clouds and sparking even more star birth. It's a self-sustaining cycle of creation, where one star's birth can lead to the birth of many others. The interstellar fireworks in NGC 1277 also provide a unique opportunity to study the early stages of star formation. By observing these regions, astronomers can learn how stars like our own Sun come into existence. They can track the collapse of gas clouds, the ignition of nuclear fusion, and the eventual clearing of the surrounding dust as the newborn star begins to shine. Each observation adds a piece to the puzzle of how stars and planetary systems form. What's truly awe-inspiring is the scale of this process. The region spans hundreds of light years, with thousands of stars being born simultaneously. Some of these stars will grow to be massive, burning brightly but briefly, while others will become smaller, longer-lived stars like our Sun. Together, they form a tapestry of light and energy, a testament to the dynamic and ever-changing nature of the universe. As we marvel at this interstellar fireworks display, we're reminded of the galaxy's role as a cradle of creation. It's not just a collection of stars, it's a living, evolving entity where new worlds are constantly being born. And with each star that lights up the darkness, we gain a deeper understanding of the forces that shape our universe. Next, we'll explore a ripple in spacetime within NGC 1277. A phenomenon that challenges our understanding of gravity and the fabric of the cosmos. What secrets does it hold? Let's find out. Now, let's turn our attention to something that bends the very fabric of reality itself, a ripple in spacetime within NGC 1277. This cosmic ripple is not just a fascinating phenomenon, it's a window into the mysterious forces that govern the universe. Imagine spacetime as a vast, invisible fabric stretching across the cosmos. When massive objects move or collide, they create ripples in this fabric, much like a stone dropped into a still pond. These ripples, known as gravitational waves, carry energy across the universe, distorting spacetime as they travel. The origins of this cosmic ripple in NGC 1277 can be traced back to some of the most violent events in the cosmos. One possible source is the collision of two supermassive black holes, each billions of times more massive than our Sun. When these titanic objects spiral toward each other and merge, they release an enormous amount of energy in the form of gravitational waves. These waves ripple outward, stretching and compressing spacetime as they go. Another potential source could be the explosive death of a massive star, known as a supernova, which sends shock waves through the fabric of spacetime. The effects of this ripple are profound. As it passes through NGC 1277, it subtly alters the paths of stars, gas clouds, and even light itself. While these changes are incredibly small, they can still be detected by sensitive instruments here on Earth. By studying these ripples, astronomers can learn about the events that caused them, gaining insights into the behavior of black holes, neutron stars, and other extreme objects. It's like listening to the echoes of the universe's most dramatic moments, but the ripple's impact goes beyond just observation. It also plays a role in shaping the galaxy itself. As gravitational waves travel through NGC 1277, they can compress gas clouds, triggering the formation of new stars. In this way, the ripple becomes a cosmic sculptor, influencing the birth and evolution of stellar systems. It's a reminder that even the most subtle forces can have far-reaching consequences in the grand tapestry of the universe. What makes this ripple truly remarkable is its ability to challenge our understanding of gravity and spacetime. Albert Einstein first predicted the existence of gravitational waves over a century ago, but it wasn't until recent years that we were able to detect them directly. Each ripple we observe provides new evidence to test Einstein's theories and explore the limits of our knowledge. In NGC 1277, this cosmic ripple serves as a natural laboratory, offering a unique opportunity to study the fundamental laws of physics in action. As we ponder the implications of this ripple, we're reminded of the interconnectedness of the cosmos. Every event, no matter how distant or violent, sends ripples through spacetime, linking the universe in a delicate web of cause and effect. And with each ripple we detect, we come one step closer to unraveling the mysteries of the universe. Next, we'll delve into the enigmatic nature of a galactic ghost, a mysterious object in NGC 1277 that emits no detectable energy. What could it be? Let's find out. Now, let's shift our focus to something that defies detection yet sparks endless curiosity. A galactic ghost lurking within NGC 1277. This enigmatic object emits no detectable energy, making it invisible to traditional telescopes and instruments. It's as if the galaxy is hiding a secret, one that challenges our understanding of what can or cannot exist in the cosmos. Theories about this ghostly object abound, each offering a unique perspective on its nature. One possibility is that it's a cold, dark remnant of a long-dead star. When massive stars exhaust their fuel, they don't always explode in a supernova. Instead, some may collapse into a dense, cold object known as a black dwarf, a theoretical end state for white dwarfs that have cooled over trillions of years. If such an object exists in NGC 1277, it would emit no light or heat, making it nearly impossible to detect. Another intriguing theory suggests that the galactic ghost could be a rogue black hole drifting silently through the galaxy. Unlike the supermassive black hole at the center of NGC 1277, this one might be isolated, having been ejected from its original location during a violent cosmic event. Without a surrounding accretion disk or nearby matter to consume, it would remain invisible, detectable only through its gravitational influence on nearby stars and gas. Some astronomers speculate that the object could be a massive cloud of dark matter. Dark matter, which makes up a significant portion of the universe's mass, doesn't interact with light or other forms of electromagnetic radiation. If this ghostly object is a dense concentration of dark matter, it would explain why it emits no detectable energy while still exerting a gravitational pull on its surroundings. There's also the possibility that we're witnessing a new type of celestial object altogether, one that hasn't yet been defined by science. The universe is full of surprises, and NGC 1277 galactic ghost could be a clue to phenomena we've yet to discover. It might represent a bridge between known physics and the unknown, challenging us to rethink our assumptions about the cosmos. Despite its elusive nature, the galactic ghost has profound implications for our understanding of the universe. Its existence, or lack thereof, could shed light on the behavior of dark matter, the life cycles of stars, and the dynamics of black holes. It's a reminder that even in the vastness of space, there are still mysteries waiting to be uncovered. As we continue to explore NGC 1277, the galactic ghost stands as a testament to the limits of our knowledge and the boundless potential for discovery. Next, we'll venture into an interstellar oasis, a region rich in organic molecules that could hold the key to understanding the origins of life. What secrets does this cosmic haven hold? Let's find out. Now, let's journey to a region within NGC 1277 that feels almost like a cosmic sanctuary, an interstellar oasis teeming with organic molecules. This remarkable area is a treasure trove of chemical compounds essential for life as we know it, offering a tantalizing glimpse into the possibility of life beyond Earth. Imagine a place where the building blocks of life are scattered like seeds, waiting for the right conditions to sprout. This interstellar oasis is rich in complex organic molecules, such as amino acids, sugars, and hydrocarbons. These compounds are the fundamental ingredients for life, forming the basis of proteins, DNA, and other critical biological structures. The presence of such molecules in NGC 1277 raises fascinating questions. Could this region be a cradle for life, or is it simply a cosmic reservoir preserving the raw materials for life that may one day find a home elsewhere? One of the most intriguing aspects of this oasis is its environment. Unlike the harsh, radiation-filled voids of space, this region is relatively shielded, with pockets of gas and dust providing a protective cocoon. These conditions could allow organic molecules to survive and even interact, potentially leading to the formation of more complex structures. Scientists speculate that similar regions in our own galaxy may have played a role in the emergence of life on Earth, making this oasis in NGC 1277 a compelling area of study. The discovery of such a region also challenges our understanding of where life might arise. Traditionally, we've focused on planets within the habitable zones of stars, areas where temperatures are just right for liquid water to exist. But this interstellar oasis suggests that life could potentially form in the vast, cold expanses between stars, where organic molecules gather in dense clouds. It's a reminder that the universe is full of surprises, and life may find a way in the most unexpected places. Of course, the presence of organic molecules doesn't guarantee life. These compounds are merely the ingredients, and the recipe for life requires the right conditions, time, and perhaps a dash of cosmic luck. Yet, the interstellar oasis in NGC 1277 offers a tantalizing possibility that the galaxy may be far more fertile than we ever imagined. It's a reminder that the search for life is not confined to planets alone, but extends to the very fabric of the cosmos. As we ponder the mysteries of this interstellar oasis, we're reminded of the profound questions it raises about our place in the universe. Could life exist in such a place, and if so, what form might it take? These are questions that drive astronomers and astrobiologists to explore further, pushing the boundaries of our knowledge and imagination. Next, we'll turn our attention to a swirling vortex of energy, a cosmic tornado that shapes the very fabric of NGC 1277. What forces drive this phenomenon, and what secrets does it hold? Let's dive in. Now, let's shift our gaze to a phenomenon that seems almost otherworldly, a cosmic tornado swirling through the depths of NGC 1277. This isn't the kind of tornado you'd see on Earth, but a colossal vortex of energy, stretching across vast distances and shaping the very fabric of its surroundings. Imagine a whirlwind of cosmic proportions, where gas, dust, and magnetic fields intertwine in a chaotic dance, creating a spectacle that defies imagination. The formation of this cosmic tornado is driven by powerful forces at play within the galaxy. At its core lies a supermassive black hole, whose immense gravitational pull and magnetic fields act like a cosmic engine, spinning the surrounding matter into a frenzy. As material spirals inward, it's whipped into a high-speed vortex, generating intense radiation and shock waves that ripple through the galaxy. This process isn't just a destructive force, it's also a creative one, as the tornado's energy can compress gas and dust, triggering the birth of new stars and even entire star systems. But the effects of this cosmic tornado extend far beyond its immediate vicinity. The swirling vortex acts like a cosmic blender, churning up the surrounding space and redistributing matter across the galaxy. This can lead to the formation of intricate structures such as filaments of gas and dust that stretch for light years, weaving a complex tapestry across NGC 1277. The tornado's influence also extends to the galaxy's magnetic fields, which are twisted and amplified by its relentless motion, creating a dynamic and ever-changing environment. One of the most fascinating aspects of this phenomenon is its role in shaping the galaxy's evolution. By redistributing matter and energy, the cosmic tornado acts as a catalyst for change, driving the formation of new stars and influencing the structure of NGC 1277 on a grand scale. It's a reminder that even the most chaotic processes in the universe can have a profound impact, shaping the cosmos in ways we're only beginning to understand. As we marvel at this swirling vortex of energy, we're left with questions about its origins and ultimate fate. How long will this cosmic tornado rage on? And what new wonders will it create in its wake? These are mysteries that astronomers continue to explore, using advanced telescopes and simulations to unravel the secrets of this extraordinary phenomenon. Next, we'll turn our attention to a region where light itself seems to vanish, a galactic shadow that conceals one of NGC 1277's most enigmatic mysteries. What lies hidden in the darkness? Let's find out. Now, let's step into the shadows, a place where light itself seems to vanish, leaving behind a mystery that challenges our understanding of the cosmos. In the depths of NGC 1277, there exists a region cloaked in darkness, a galactic shadow where an unknown object blocks the light from reaching us. This isn't just an absence of light, it's a cosmic puzzle, a void that conceals something extraordinary. The galactic shadow is a phenomenon that defies easy explanation. Unlike a black hole which absorbs light entirely, this shadow is caused by an object that obscures light without completely consuming it. Imagine a colossal structure or a dense cloud of matter positioned perfectly to block the light from stars and other luminous objects behind it. The result is a patch of darkness that stands out starkly against the glowing backdrop of the galaxy. Studying this shadow is no simple task. The object responsible for it remains hidden, its nature and composition a mystery. Astronomers face significant challenges in trying to uncover what lies within this dark region. Traditional methods of observation which rely on detecting light are rendered ineffective here. Instead, scientists must rely on indirect techniques, such as analyzing the gravitational effects of the object or studying how it distorts the light around it. These clues offer tantalizing hints but leave many questions unanswered. One possibility is that the shadow is caused by a massive, dense cloud of interstellar dust and gas. Such clouds can block light effectively, creating regions of darkness within galaxies. However, the scale and persistence of this shadow suggest something more unusual, perhaps a structure or phenomenon we've yet to discover. Could it be a remnant of an ancient cosmic event, or even an entirely new type of celestial object? The possibilities are as vast as the shadow itself. Another intriguing theory is that the shadow might be linked to dark matter. While dark matter doesn't interact with light, its gravitational influence could shape the distribution of matter in ways that create such shadows. If this is the case, studying the galactic shadow could provide valuable insights into the elusive nature of dark matter and its role in the universe. The challenges of studying this shadow are matched only by the potential rewards. Unraveling its secrets could shed light on some of the most profound questions in astrophysics. What lies hidden in the darkness? How does it shape the galaxy around it? And what can it teach us about the unseen forces that govern the cosmos? As we peer into this enigmatic shadow, we're reminded of how much remains to be discovered in the universe. It's a humbling reminder that even in the vast expanse of space, there are still mysteries waiting to be uncovered. Next, we'll turn our attention to an object that sparkles like a cosmic gem, a massive diamond-like structure drifting through NGC 1277. What secrets does this interstellar treasure hold? Let's find out. Now, let's shift our gaze to something that glimmers with the brilliance of a cosmic jewel, a massive diamond-like object drifting through the depths of NGC 1277. This interstellar diamond isn't just a dazzling spectacle. It's a rare and fascinating phenomenon that offers a glimpse into the extraordinary processes at work in the universe. The formation of this diamond-like object is as intriguing as its appearance. Scientists believe it could be the remnant of a white dwarf star, a dense stellar core left behind after a star has exhausted its nuclear fuel. Under immense pressure and heat, the carbon within the star's core crystallizes, forming a structure similar to a diamond. Over billions of years, this crystallized core cools and hardens, eventually becoming the massive, diamond-like object we observe today. Imagine a celestial gem forged in the heart of a dying star and cast adrift in the vastness of space, a true cosmic treasure. What makes this object so rare is the specific conditions required for its formation. Not all white dwarfs undergo this transformation. The process demands an exact balance of temperature, pressure, and composition, making such diamond-like objects incredibly uncommon. In fact, this interstellar diamond is one of only a handful of similar objects ever detected in the universe. Its discovery in NGC 1277 adds another layer of wonder to this already mysterious galaxy. The sheer size of this diamond-like object is another aspect that sets it apart. While diamonds on Earth are measured in carats, this cosmic gem spans thousands of kilometers, dwarfing anything found on our planet. Its immense scale and crystalline structure make it a unique subject of study for astronomers, offering insights into the life cycles of stars and the extreme conditions that exist in the universe. But the interstellar diamond isn't just a scientific curiosity, it's also a reminder of the beauty and complexity of the cosmos. Its glimmering presence in NGC 1277 serves as a testament to the incredible forces that shape the universe, from the birth and death of stars to the creation of objects that defy our imagination. As we marvel at this cosmic gem, we're reminded of the endless wonders waiting to be discovered in the depths of space. Next, we'll explore a region where sound waves echo endlessly, creating a phenomenon unlike anything else in the galaxy. What secrets does this cosmic echo chamber hold? Let's find out. Now, let's step into a region of NGC 1277 where the laws of physics seem to bend in the most extraordinary way. A cosmic echo chamber where sound waves travel endlessly, creating a phenomenon that defies our everyday understanding of sound. Unlike the silence we associate with space, this region is alive with vibrations that ripple through the fabric of the galaxy, offering a unique auditory experience if only we could hear it. The science behind this cosmic echo chamber is as fascinating as it is complex. Sound waves, as we know them, require a medium to travel through like air, water, or solid materials. In the vacuum of space, sound typically cannot propagate because there's no medium to carry it. However, in this specific region of NGC 1277, the presence of dense clouds of gas and dust creates an environment where sound waves can indeed travel. These clouds act as a cosmic conductor, allowing vibrations to move through them and bounce back endlessly, creating an echo that persists for unimaginable lengths of time. What makes this phenomenon even more intriguing is the scale at which it occurs. The sound waves in this region aren't the high-pitched tones or deep rumbles we're familiar with on Earth. Instead, they are low-frequency vibrations, often referred to as infrasound, with wavelengths that can stretch across vast distances. These waves are generated by colossal events such as the collision of galaxies, the explosive death of stars, or the intense activity around black holes. Each event sends ripples through the gas and dust, setting off a chain reaction of echoes that reverberate through the cosmic chamber. The endless nature of these echoes is due to the unique structure of the region. The gas and dust clouds are arranged in such a way that they trap sound waves, preventing them from dissipating into the void of space. Instead, the waves bounce back and forth, creating a continuous loop of vibrations. This creates a kind of cosmic symphony where the echoes of ancient events still resonate, offering astronomers a rare opportunity to study the history of the galaxy through sound. But why is this cosmic echo chamber so important? For scientists, it's a window into the dynamic processes that shape galaxies. By analyzing the patterns and frequencies of these sound waves, researchers can learn about the density and composition of the gas clouds, the energy of the events that generated the waves, and even the structure of the region itself. It's like listening to the heartbeat of the galaxy, revealing secrets that light alone cannot uncover. As we marvel at this cosmic echo chamber, we're reminded of the interconnectedness of the universe. Even in the vast emptiness of space, sound finds a way to persist, carrying with it the echoes of events that occurred billions of years ago. It's a testament to the enduring nature of the cosmos and the endless wonders it holds. Next, we'll turn our attention to the final strange object in NGC 1277, a mysterious entity that defies all current explanations. What could it be? Let's uncover the secrets of this galactic enigma. Now, as we approach the final chapter of our journey through the strange and wondrous objects of NGC 1277, we encounter the most baffling of them all, a galactic mystery object that defies all current scientific explanations. This enigmatic entity, shrouded in secrecy, has left astronomers scratching their heads, sparking countless theories and fueling ongoing research to uncover its true nature. What makes this object so perplexing? For starters, it emits no detectable energy, no light, no radiation, no signals of any kind. It's as if it exists in complete silence, invisible to our most advanced telescopes and instruments. Yet, its presence is undeniable, inferred through its gravitational effects on surrounding matter. Stars and gas clouds near this object behave in ways that suggest something massive and unseen is lurking in the shadows, pulling the strings of the cosmic dance. One leading theory suggests that this mystery object could be a new type of black hole, one that doesn't fit the traditional models we've come to understand. Unlike the supermassive black holes at the centers of galaxies or the smaller stellar black holes formed from collapsing stars, This entity might represent a middle ground, a so-called intermediate mass black hole. These elusive objects have long been theorized but have yet to be definitively observed. Could this be the breakthrough discovery scientists have been searching? Another possibility is that we're looking at a massive concentration of dark matter. Dark matter, as we know, doesn't interact with light or other forms of electromagnetic radiation, making it invisible to our instruments. However, its gravitational influence is undeniable, shaping the structure of galaxies and the universe itself. If this mystery object is indeed a dense clump of dark matter, it could provide invaluable insights into the nature of this mysterious substance that makes up a significant portion of the cosmos. Some researchers have even proposed more exotic explanations, such as the existence of a primordial black hole, a relic from the early universe that formed not from the collapse of a star, but from the extreme densities present shortly after the Big Bang. These ancient objects, if they exist, could offer a glimpse into the conditions of the universe in its infancy, providing clues about the origins of everything we see today. Despite the many theories, the true identity of this galactic mystery object remains unknown. Ongoing research continues to probe its secrets, using cutting-edge technology and innovative methods to detect what conventional instruments cannot. Each new observation brings us closer to understanding this cosmic enigma, but for now, it stands as a testament to the boundless mysteries of the universe. As we conclude our exploration of the 50 strange objects in NGC 1277, we're reminded of how much there is still to discover. From supermassive black holes to cosmic echo chambers, each object has revealed a piece of the galaxy's story. Yet the final mystery reminds us that the universe always holds more questions than answers. What do you think this enigmatic object could be? Share your thoughts in the comments below, and don't forget to subscribe for more deep dives into the wonders of space. Until next time, keep looking up. The cosmos is full of surprises. And so, we reach the end of our cosmic journey through the 50 strange and fascinating objects of the NGC 1277 galaxy. From the supermassive black hole at its heart to the enigmatic galactic mystery object that defies explanation, each discovery has offered a glimpse into the incredible complexity and wonder of our universe. These objects are not just curiosities, they are keys to understanding the forces that shape galaxies, the origins of the cosmos, and the mysteries that still lie beyond our reach. The supermassive black hole challenged our understanding of how such giants form, while the dark matter halo reminded us of the invisible scaffolding that holds galaxies together. Ancient star clusters whispered secrets of the early universe, and rogue planets drifted silently, untethered from any star. Colliding galaxies painted a dramatic picture of cosmic evolution, and quasar remnants hinted at the violent past of the universe. Neutron stars, cosmic strings, and hypervelocity stars pushed the boundaries of what we thought was possible, while dark stars and magnetic monopoles teased us with their theoretical existence. Each object, whether observed or theorized, has added a piece to the puzzle of NGC 1277. Yet, as we've seen, the galaxy is far from fully understood. The mysteries of dark energy, interdimensional portals, and galactic ghosts remind us that the universe is a place of endless discovery. Every answer we find seems to lead to new questions, and that's what makes space exploration so thrilling. As we wrap up this exploration, we invite you to reflect on these wonders. What do you think lies at the heart of the galactic mystery object? Could it be a new type of black hole, a massive concentration of dark matter, or something even more extraordinary? Share your thoughts in the comments below. We'd love to hear your ideas and theories. If you've enjoyed this journey through the strange and mysterious objects of NGC 1277, don't forget to hit the like button and subscribe to our channel for more deep dives into the wonders of space. The universe is vast, and there's always more to explore. Until next time, keep your eyes on the stars and your mind open to the endless possibilities of the cosmos. Thanks for watching, and remember, the greatest mysteries are still out there, waiting to be uncovered.